So this is where we are right now. Um, yeah. Uh, it's super basic. Like literally, it's just cubes that we can subdivide and destroy. And I think that's where we're going to start. So the idea here is I want to be able to destroy these cubes in a way that makes a little bit more sense than what we have right now. Like right now, I can toggle destroyed on them individually, and it destroys the cubes, but I would like to be able to use some sort of explosion or something, so we have a little bit of a better way to actually remove these things. So the first thing we're going to do is create sort of a sphere that is going to take every cube inside the sphere and then subdivide that, and automatically toggle this destroyed flag for everything inside of that sphere. And then once we do that, we're going to add health, I think. And then once we have health, I think we're good, because then we can just start subtracting health. So that sphere will subtract some health from it instead of manually deleting or damaging things. And so that way it makes just a little bit more sense, and we're actually hurting things. And then, yeah, live stream. We haven't done one. We've done a few. I've been trying to get back into them, but it's been months since since I've done one, or done lots of them. So yeah, hopefully there will be more and more of these. Just because like these longer projects, it just makes more sense to live stream them than to cut them into a bunch of videos, because we'll end up with like hundreds. So hopefully we can just get all of that done. I'm hoping it only takes like an hour or so to get all of that destruction stuff working. And then we can start building up some other new things. I'm not really sure where or how this is going to go, but I'm kind of hoping that we can get something really scrappy going. And then with the scrappy stuff, we can kind of start making it better and better and better and figuring out what works. But I don't think we're on the right path of trying to like nail everything and get everything correct the first time. I don't think that's the right solution to this. So we're kind of changing this a little bit and hoping to kind of get it done, get a prototype out, and then iterate on that and kind of start working on improving the mechanics around that. So talked about that enough. Let's do destruction. So with this, let's have a sphere impact. That's all kinds of a terrible name, but let's try it anyway. And so what I want to do is give this a public vector 3, and that will be the position. So we're going to be able to position this thing and then have it explode somewhere. And so the idea here is if detonate, then detonate equals false, and we'll do something with that. So this will be public bool detonate. And so this will work very similar to our asteroid subdivision controller. So we have this destroyed flag. We're going to do the same thing, but for the sphere impact. And then that will set the destroyed flag for everything else. At least that's sort of what I'm hoping will end up happening. And so what we want is some sort of physics dot sphere. What's the name for this? We want to check a sphere. So check sphere, if I'm remembering correctly, is going to test whether something is in that sphere or not. So that will tell us if there's something occupying that, which I guess is good. But what we actually want is an overlap sphere. And this is going to return us a list of all of the colliders that are in that collision area. So we can give it the position, our radius, a layer mask if we want. I'm not going to do that, I don't think. Yeah, so that's optional, so we can just ignore that. Let's add in this radius. So public float, give it a radius. And then with this, this will be our hit objects. And then with all of those, for each hit objects, or let's, if we're trying to do this quickly, I would actually prefer to use link for this. And what we can do, what did I press? Something bad. That's the wrong thing. Oh. Okay, so control plus or control period is the bring up this auto completion thing in Visual Studio Code. That's the hotkey for that. But Windows period is the emoji thing, which we don't want. With furry peas or some kind of enlarged weevil. I don't think we're going to go that route. Maybe you can mod that in afterwards. I haven't really figured out whether we're going to open source this or not. I do have it all in Git, but it's not in a public Git repository, so you guys cannot grab this code right now, just because I haven't really figured out how we're going to release this. But yeah, I don't know. We might do some fun things just to kind of do that. I am going to turn my mic down just a bit because we're capping it out right now. So let's see here. Hit objects. What we want to do is well, let's import link because without that, it's going to be really hard to tell what we're doing. So let's get that in. So I've covered link in other videos, but I'll go over it quickly here. What it effectively lets you do is chain a number of commands. So what we're going to do is pass every hit object in. So this will be our object, and we're going to pass that in and say the object.getComponent of type subdivision controller or subdividing destruction. So that will get all of those components out, and then where the destruction, let's not call it that, let's call it the behavior, is not null. So behavior is not null. Then let's do something with it. And so we can make this a little bit nicer. There we go. Getting all sorts of messed up there. So this is going to kind of select our object from our hit object. So that's going to take the collider out of there. And then for each of those, it's going to look at the components attached to that and try to find a subdividing destruction controller and return that. And then what this ends up doing is select will transform that the return type into the return of this. So this behavior now is a subdividing destruction behavior because we've grabbed it from here. And so this returns null if we don't find anything. And so what the where is doing is filtering that out. So we don't get anything there if our where block fails. And so everything after this point is going to be a subdividing destruction object that we can do stuff with. And what we want to do is invoke some sort of function, which I have forgotten how to do. That seems kind of important. So let's what's the there's a function for this that I don't remember how to do. For all? That doesn't seem right. Yeah, okay. I want to look this up before I get too far. I realize that at this point, it would have been easier if we had just used the for each, but this for me is a lot easier to reason about. Longer term, it's a lot easier for me to see what's going on because I kind of know those keywords than it is to look at a for each loop because that can be almost anything. So how does this work? A function to test each element for a condition. Okay, so that is going to be very similar to our where. So we could actually replace that with all. So that's going to get all objects that match this predicate. So it's using predicate logic, which means that there's a function that returns a Boolean. The function takes in the behavior and then returns some sort of Boolean. And the ones that return true are the ones we're going to use, which is going to be all the ones that are not null. And then That's not going to work. This seems silly. Because I don't want to just call a for each on this object. That doesn't make sense. And I don't really want to cast it into a thing. Oh, what's this doing? Oh, never mind. All returns a Boolean of true if everything in the function matches that. So if everything is a subdividing destruction controller, then that would return true. We don't want that. Well, this is just silly. All right. Element at first or default, join. I'm missing the function here, but that's just silly. Okay. Aggregate? No? It's parallel? No? Okay. Well, we're not going to do that, I guess. That's just not going to happen. So I guess we can do this, which is going to convert it to a list and then call for each on that, which looks something like toList dot for each, which is not great. There's a lot of things about weevils in chat. Okay. All right. So behavior, and what we want to do is set the for each behavior dot is or destroyed equal to true. So effectively what this whole block of code is doing is selecting everything in a circle, and then for all of those things, it's finding the ones that have a subdividing destruction object attached to them, and then for each of those, it is setting the destroyed value to true. And so that it should cover all of this. And so if detonate is true, we set it to false and do this at the position with the radius. Okay, cool. Which means let's add on draw gizmos, just so we kind of know where things are working. So this is going to get called, with link, it's going to get called only when the detonate is true. So it's not going to get called every frame. But I do agree, doing this every frame would be a little bit excessive. Even the way I'm using it, it's probably a bit excessive. But for this, what I'm kind of hoping to do is get code down that's easy to understand and is something that we can come back and fix later. So we're not trying to optimize for performance. We're not trying to optimize for like really good abstraction patterns or anything like that. We're not trying to pull in a lot of libraries that would make our life easier. What I'm trying to do is get the core game working, and then we can start finding things that aren't working exactly how we want them or are a little bit slow, and start pulling those back out and making them a little bit better. And I think that will leave us in a better spot, because then some of the stuff that doesn't matter, like this code, is not going to stay around for very long. And so if it looks like this, it's easier to reason about. And when we pull it out, we're not losing a lot of stuff. So that's sort of my thinking around this. But I definitely agree, for link, you shouldn't be calling it in an update, because it's just going to be doing a whole bunch of extra stuff that you don't want to happen. So let's draw a wire sphere to represent what we're doing here. So position and radius. And let's make that blue, because blue is a nice color. Blue, cyan? Sure. All right, so that will at least tell us where that destruction thing is. And so what I'm hoping, so no, it won't exit immediately. when we set this to false. So even though I'm setting this to false immediately after getting in, the check has already happened. And so because we've already done that check to see if our detonate is true, we're inside of this block. So until we exit it and try to get back in, it's going to treat it as if we're true. It's like you can open a door to like walk inside. And then if you close it, you still got inside. And so we're on the inside of our house or whatever, and we can do everything inside of that house. But the door is now closed. And so nobody else can get in. But if we want to do that again, we can set this to true and unlock the door again, so something else can get in. Hopefully that makes some sense. So let's create a sphere impact object. So this will just be like our test thing, sphere impact. I have added this game controller since the video that I did on this. And it just has this cube thing. And so, yeah. Oh, also, I should mention this because this is kind of cool. When you're working with code, for example, like what I have this asteroid spawn controller that requires a prefab in order to create something. There in Unity in the inspector, when you select the script, there will be options on the right-hand side. Like you can see this chunk prefab. These are the default values for this script, which means that every time I apply this script to any other object in my scene, it's automatically going to have these values, which is really handy for like setting up prefabs and things that you don't necessarily aren't able to do in code very easily. You can do it by referencing the code object, and Unity will keep track of that for you, which means if I were to like drag that script over onto something else, it would work, which is actually how this got set. I didn't set that one manually. So that's just sort of handy, I guess. We're running this, so we should be able to just trigger this. We're going to need a radius of some kind, so let's give it a radius of 5. And so what I'm hoping will happen here is this will subdivide until everything is a box of 1. And then when they get to 1, anything below that, it gets destroyed. And so what ends up happening is, or what I'm hoping will happen, is if we move this to like the top, for example, of like 4, we should be able to create this crater in the top by detonating this 4 or 5 times. So if we do that, we see that it did subdivide. You can see the little shadow thing, which just happens because we're working with cubes and the shadow stuff or lighting is a little bit weird. But if we do this again, we get another subdivision, and you can see a whole bunch of cubes get added on the left-hand side. We do it one more time, and now things should be at a size of 2. Yeah. No, they're at a size of 1. Okay, cool. Which means that things should get destroyed the next time we trigger this. And now we have just this circle impact of what happened, which means that our destruction system is actually doing what we want. Kind of a weird, janky manual test, but it does work. And so I think that proves enough for what I want to do. And so I think the next step is to add some health. So let's add some health to a new object, I think. And so what we're going to do is fundamentally change how this whole thing works. Instead of having this subdividing destruction controller control when things are destroyed, I want to shift things over so that we're actually having something track the health. And then this is what's controlling the destruction. So the advantage of doing that is if this breaks, or if I want to swap this out, I can do that without changing any of the logic that affects how everything like damages one another and things like that. And so I can swap in new spawning mechanics without breaking other things. And so it just makes it a little bit easier that way. So health tracker. We actually built one of these in a previous video. There's some changes that I want to make, and it's going to be a little bit simpler and a little bit more complicated at the same time. So we'll see. But for now, I think we can just do public float health equals that. And then let's see, start. We don't care about that. And then update if our health is less than or equal to 0. we want to destroy this. Is destroyed. So we can do, previously what we had done is we had used event handling. So this would fire an event. That actually might be the best solution. So let's set that up. So I think it was public Unity event, Unity engine.event. Okay, this is wrong. Public class, Unity engine.event, event, sorry, which is going to extend a Unity engine. Okay, struggling with spelling. That's great. Event. There we go. And so I don't think that, I think that accepts generics, but I might be wrong. So let's do that. See if we're correct. What does this do? Takes in an event. That doesn't seem right. That doesn't seem like the kind of event we want. We want a Unity event. No. Events. There it is. All right, we got there in the end. Unity base event, I believe. No. Unity event. All right. So this is going to be our Boolean event, because I believe this Unity event base, one of these accepts a generic thing. Clearly I'm wrong. We'll see. So this is going to take in a Boolean, and we're going to fire that. So public Unity event. Why can't it find those? Unity engine .events .unity event. It should be able to find what I'm giving it, but it can't. Okay, weird, very weird. So what does this say? There's a Unity event. Okay. Unity engine events, Unity event. On destroy. Sure. But I want this to have a generic argument of a Boolean or a bool. And so does this work? Yes. Okay. So there is our T0, which gets passed in there. And then we need something else. Actually, we don't really need to pass anything in. Because we're using a bool, or we're using a basic serializable thing, I think we're good. But we'll see. And so what we can do is on destroy question dot. So this is a nullable terminator question mark. And so what this does is checks if the first value, if the left hand side is null. If the left hand side is null, it stops. But if it is not anything that is not null, it is going to invoke the right hand side, which means we can do something like that dot invoke and give it a true. Do we even need this? We probably don't need that. So let's just take that out, and there we go. And so the reason you want that null terminator is if you have no events attached to your onDestroy method, that's going to be a null thing. And that means your code will break and your game will crash if you don't check for nulls. And so that's what we need to do here, is just make sure that things are null. So that should fire the onDestroy event. And then really all we need in order to make anything else work is for them to subscribe to the onDestroy event. And so how do we want to do that? We can have this subscribe other things to the onDestroy event. And so what that might look like is a void start what would that look like? Get component of type subdividing destruction. If that's not null, then do something else. So let's do an if here. So if this is not null, then subscribe this and do on destroy plus equals. Unity doesn't like that, so we have to add a listener instead, which is going to look something like that. And then it's just going to say the subdividing destruction controller is equal to null. And since I didn't save a reference to that, it's not going to work. But we're not going to do this anyway, so it doesn't really matter. But that's just sort of how this would work. If we wanted to invert this, right now I don't think that makes any sense. I don't think we want to do that, so we're not going to. So let's do this. Inside of here, let's add a subscribe function to this. Public void subscribe to on destroy. Does that make sense? So the reason I'm considering doing this is if we call this, we can use the null terminator to kind of make this a little bit nicer. And so what we can do is give it a unity action. That's wrong thing. There we go. And since I just added that to the using, those can go away. And so this will be our action. And effectively, we're just saying, add this to the on destroy. Does that make any sense? I don't think so. Let's get rid of that. I don't like that. Instead, let's just do get component health tracker question dot. So if we find a health tracker, we want to use on destroy question dot. So a lot of these questions just to kind of make sure that we're actually getting something. And we'll do add listener. And this expects some sort of action. So we're going to subscribe to this and say destroyed equals true. And so this line of code is going to go and grab a health tracker and then check to make sure that we found one. If we did, it's going to grab the on destroy event out of that. If we find one of those, then we're going to add a listener that sets the destroyed of this to true when the health tracker is saying that it's been destroyed. And so that should cause everything else to kind of destroy itself. And so that should handle this, I think. We'll see. And we can delete this. All right. Unity event, we don't need that anymore. We've got that documentation. So the sphere impact is what actually needs to do something. And so what we're going to do is be changing most of this actually. So we're going to be changing our health tracker. So instead of grabbing the destruction controller, we're grabbing the health controller. I'm using controller here as sort of a reference of things that own a specific portion of what I'm doing. And so previously we just had destruction as a feature, but now we have destruction and we have health. And so what we want to impact is the health, and the object will control its destruction. And so health tracker is going to be what we're going to find. If it's not null, then we want to grab that and do behavior dot health minus equals damage, whatever damage is. And so that will be some new value we'll add here. So float damage. And this is going to mean that we can inflict damage in a radius. And so hopefully, if I've done this right, we will now be able to do everything we just did, but with a little bit more control. At least that's the goal. If that doesn't happen, then we didn't really do what we wanted. But first we need to update our prefab because our prefab needs that new script. So we need to add this health tracker and set some sort of default health. We'll say 100. And so that will be like the default new game object. Open. Actually, I'm doing this wrong. I was editing Unity's new 2019 prefab stuff, nested prefab stuff. I still am not familiar with it. So there we go. So this should be us modifying the prefab. You can see we kind of have that open now instead of our scene. So if we save this, that should have saved the prefab. And now we have 2 of these. So what I want to do is revert there. So that reverts our prefab back to the defaults. And so now we have the health tracker component and the subdividing destruction component. This should find this and subscribe to it. And then when the health becomes 0, we should see it get destroyed. And so if I go and set, did I delete our, I deleted our sphere impact thing, or I had it in some other sphere. Sure. Let's give it a radius of 5, position, damage 100, which means that it should automatically destroy things when we trigger this. I want to do that first just to make sure we have the subscriptions all working, and then we'll lower that to make sure that we don't always destroy things when they get dealt damage. And that should cover both of those. And we'll see. And we have 2 spheres. I need to delete this one. There we go. Let's try that again. So let's bump this. Oh, right. We have 2 positions. We have the transform position, and then we have our position for our actual tool. So let's position that there. And we can see it got destroyed because we now have 8 cubes. And so if I lower this damage down to 50, the first one shouldn't destroy anything, and the next one should. And then we can keep going until we end up with this. So now we've actually got some destruction, but we've also got damage, which means that we can sort of gradually inflict some damage instead of just always destroying things. So I think that's a good place to be. What I don't like is we now, for everything that can take damage, every frame we're checking if it's been destroyed. I don't particularly like that. So what we're going to do is change this to damage, deal damage. I don't know a good name for it. And so that we'll give it a damage value in. And then what we're going to do is do health minus equals our damage, and then do this check, which means that we're not going to make it possible to modify this health. That's the next step. Instead, what's going to happen is you're going to invoke this deal damage command. And when you do that, it will cause things to get destroyed. And so we only check for destruction when those things are dealt damage. So as long as everything goes through this to deal damage, it means that we only need to check for destruction when we actually are doing that damage. So we save a lot of that work for those other things. So effectively what we need to do is change this from behavior.health minus equals this to behavior.deal damage of damage. There. And so this should, inaccessible due to its protection level. We need to make this public so everything can see it. And now we're good. So we deal the damage, invoke everything, and I think we're done. And so everything should still work if I have done this correctly, which isn't always the case. So I guess we should test. But we can, there. And so now we can destroy things. That was kind of lame. Let's make the radius 4. And hopefully we get something a little bit prettier. But now we're only doing that check every time that we actually invoke that deal damage command, just so we don't constantly waste all that time checking things, because the goal of this game is to have a lot of objects, because it's just more fun that way. In the tests that I've done in the past, the more things we can get thrown at the player, just the more fun it is. And so anything we can do to kind of make that easier to do is usually a good thing. And this kind of helps with that design aspect of kind of event-driven things. Instead of a polling-based system where you're constantly checking, did I take damage? Did I take damage? Did I take damage? Instead, we're doing an event-driven thing of saying, you took damage, do things based off of that. And so this is sort of based off around that. And personally, I really like event-driven systems. Maybe that's just because I worked on them a lot. But yeah. All right. So damage, everything is good. I think what we want is physics, right? Because right now this whole thing is kind of lame, and that I'm not trying to be mean, but it's just like there's nothing happening, and so let's make things happen. Let's add a rigid body to this. Move it up and move it up, and disable gravity. We're in space, so there's no gravity. Well, no gravity that matters in our game. There is still gravity in space, but it doesn't matter. And so we do this, and we shouldn't see anything change, I'm hoping. Yeah, so everything is still the same. And I imagine as we destroy things, nothing will happen because there's nothing colliding with anything. But if I were to move this down, we end up with this. And so this is the effect that I want to create next. And so when we explode in this circle, I want to apply an outward force to everything inside that circle. And so what's the best way to do this? Is there to apply like some sort of I guess we already have a way to apply forces, so we're going to use that, and we have this sphere impact. So for now, we're going to program this as if all of the weapons, like effectively the sphere impact code is functioning like a weapon. It is dealing damage and it's going to be applying physics. We're going to keep it that way, so we don't have any like central object that does those things. Instead, we're going to be the ones applying those. And so what that means is, in addition to grabbing all of these hit objects, what we also want is to do hit objects.for each. What? Hold on. That doesn't make any sense. Let's do that. Swap in a for each and do rigid body. For each hit objects dot select object, and let's select the rigid body out of there. So get component rigid body. So we're going to grab all the rigid bodies out of the components we've hit, and then I would like to apply a force onto that. So we're just going to add this where clause just to make sure we're not grabbing null objects. And that probably shouldn't be a problem, but if it were to become one, it would just be annoying. So we're going to avoid that. What's going on? Get component dot rigid body. Oh, I didn't close the select. There we go. All right. Parentheses. Cool. And so now we're doing all of that. This is just another way to do that for each that I did above. I'm not sure which one is better, but we're going to do both because that's just what's going to happen. And so now we have all the rigid bodies. So let's do rigid body dot add force at position. Add force, add explosion force. That seems like what we want, right? We want an explosion. So explosion force, explosion position, and explosion radius. Sure. All of those sound great. So let's grab the explosion force. We'll grab force. Force, there we go. The position and the float radius, which will be our radius. And I think that's everything we need. So all we need to do is define force, which I believe is like meters per second, or there's something. I'm really bad at this, so I usually just base it on what feels good. And we're not to a point where that can be done. So I'm probably going to set that lower than it might make sense. And we can kind of tweak it from there. But let's set it to 1 for now. I just want like some amount of force, just so we have some sort of physical thing. Because otherwise it's all going to just stay together. And that doesn't really make sense. So let's apply some damage here. I should point out, because everything is so separated, if I were to click destroyed here, we destroyed our object, but we didn't apply any force. We didn't do any of the health checking. Nothing really happened there because we kind of skipped most of the steps. What we actually want to do is click detonate here, and that will blow them up. And I can't tell if anything happened. Let's try that again. Well, that's lame. Let's set that to 100 and set damage to 1, increase our radius, and go boom. All right, so it does work. Cool. And so that's sort of our explosion. Part of the issue with tweaking these is it's a function of the size of the rigid body, and it's a function of the volume of the rigid body and the mass of it. And so as objects get smaller and have a lower mass, they will be affected more. Our mass is constant, but our volume is not. So things should change, if I'm understanding this correctly. But there's destruction. And theoretically, if we do like 100 and just do that. Oh, cool, it applies rotational stuff too. Well, that's handy. That means we don't have to. So that's all good. I'm trying to think now. Everything that we have in this game is rotating. And so what I'm trying to decide if it makes sense is when we're rotating our objects, if we just destroy them, like if our object is rotating and we just destroy it, that rotational velocity is going to go away. And what I would like it to do is to get some force along the tangent of where it is, so that effectively those objects just go flying away from where they are. I'm thinking we can make that happen. Maybe. But I don't really know. I don't really know how. So let's try to get that to work. So subdividing destruction, let's apply that here. So we create our subchunk, do it like this. Why did you get wrapped? That's weird. All right. And so there is our world position, which is our transform position. We multiply the vector. That gets us into a world position relative to our thing. So we have this relative subchunk location, and we have a rotation axis, hopefully, that we're going to be rotating on. So what I think we can do is grab the cross product of those and turn that into a vector. So if you're not familiar with what a cross product is, if you use like the right hand rule, which is take your three top fingers, so your thumb is your Y, your pointer finger is your Z, and then your middle finger is your X. You can do it with your left hand too. The way this actually works is one is DirectX and one is OpenGL, I believe, is how that ends up working. But effectively, the way the cross product works is if you give it two of these vectors, so say forward and to the left, then the result will be up. And so we can use that by taking the axis of rotation and our relative location to the center of the mesh and translate that into a vector that is going tangent to that, if that makes any sense. I think that should make sense, or should work. I don't know if it makes a lot of sense, but that's sort of what I'm going to try to get to happen. And so what we should see is sort of this vortex of things going in 4 different directions, because we're subdividing a cube. So we should see 4 different directions happen. If they go in 8, we've done something very wrong. But yeah. So how is this going to work? First, we're going to need our rigid body. Equals, let's see, we have our spawn chunk. So this gives us all of that. We need to spawn the chunk, and let's grab our instance out of that. And so that doesn't return an instance right now. We're going to ignore that and do instance.get component rigid body. And then if rigid body is not null, then we're going to do all this other stuff just to kind of safeguard us against returning null. Maybe our object doesn't have a rigid body for whatever reason. If that happens, let's debug log error asteroid chunk detected with no rigid body connected. And so that will log in errors, just saying something very wrong happened. If we see this, check to make sure asteroid prefab has rigid body connected. And so that hopefully just gives us a little bit of a hint that says, hey, we screwed up and we can fix that. All right, so otherwise, we're going to do some math here just so we actually get to the right point, because I don't think it knows what type this is. Yeah. So let's go into our spawn chunk and return a game object from here, which we can call our subchunk. And so that's just going to give us the game object that we created back. So we can do some other things like what we're going to do here. Just because I don't want to do that in the chunk creator bit, because that doesn't make a lot of sense. Because all that is there for is to create these new chunks at these positions and with these rotations. But what we want is to actually create it with other things. And so by doing that in here, we're kind of isolating what's working on what. This is working on the destruction, and that's working on the spawning thing. So hopefully we're good. We get our rigid body out of there. If it's not null, we want var direction equals this dot get component of type rigid body is not. How do we want to do this? Parent rigid body, maybe. That might get a little bit gross, but sure. This will be our angular rotation equals our parent rigid body dot get. So that's that's that. So that's our rigid body. Now we want the angular rotation, which is going to be equal to the parent rigid body not null. So I'm doing a ternary operator here just to check if the parent rigid body is null or not. If it is, we're going to need to use some sort of default, which I'm just going to use vector3.up, which is just up, just because we can choose whatever we want. but just so that there's some behavior if things go horribly wrong. And this is the best that I can think of. What VR platforms are we targeting, and what is your target frame rate? Right now, HTC Vive, because that's the one I have. Eventually Valve Index, because I have one of those pre-ordered. And so hopefully we'll be able to target that as well. But for right now, not really that far into the project to be able to say. I would think that we should be able to do Oculus as well. But I've never used Oculus and I don't really know. But also it should function fine on most devices. And I don't really have a target frame rate because I don't really know. But for what this game does, if you haven't seen, maybe I should pull that up. Hold on. I have a demo I recorded a while ago of what flight looked like before I restarted the project. And I'm hoping either later today or tomorrow we can start building that. And so, Asteroids VR. It's a private video. So I'm imagining many people haven't seen this. But yeah, I'll definitely, when I get further, I'll reach out for testers. But I kind of want to start with like local things, and because when I start looping other people in, it gets harder and harder to get meaningful feedback quickly. Just because there's that pattern of I have to upload something, somebody has to download it and play it, and then tell me, and there's just a long cycle there. So this is inside of the channel, but this is sort of a very old demo of what VR flying looked like. And so the problem with this is it is extremely nauseating if you have a low frame rate. Even if you have a good frame rate, this is super weird because you can flip upside down and side to side. Like this is demonstrating like you can lean your controllers forward and you'll literally just do a flip, which is the weirdest thing when you're not actually connected to anything. And honestly, watching this video is worse than playing the actual thing. But doing this in real life is super fun. Like you feel like Superman, and so it's just super cool. And hopefully I'm hoping to add like grappling hooks, so like a combination of Superman with Spider-Man in space with explosions, which just is super cool. But yeah, this is sort of like where the flying will end up. And I kind of have already worked this out. We've done this in the past. Yeah, I imagine. So I spent probably about a year working on getting this to work. Just like trying to think of different ways to do this. And so effectively what I kind of settled on was it's based off of the chain. Like it creates a bar between your two controllers, like a virtual bar. And then based on the change in that vector, your thing does different things. So you can use both if you want to, like I'm using here. But you can also just use one and kind of like hold it and manipulate it yourself. And then use the other one to like throw explosions or use a grappling hook or whatever. But this was just sort of like when I felt the flying was good. Because previously it was using like thumbsticks and things like that to kind of rotate you. And it just wasn't good. And there was like some special algorithm that tried to detect the nearest face and face you towards that. And that didn't work great either. But yeah, that's sort of what the flying is going to be. So as far as frame rate goes, it's much better when that's higher, because when that drops below a specific level, it just becomes like unplayable. And more so than other games. Like when like Beat Saber or something starts lagging a little bit, it feels a little bit choppy and you don't feel as like immersed, but you don't feel physically sick. That's not what happens here. This will make you sick if that doesn't happen. And so there's like that balance that we'll need to figure out. But for now, I don't think frame rate is going to be a problem because we don't really have a game. So So yeah, we'll work on that in the future. But yeah, I figured I'd show that because it's, I don't know. I was really proud when that actually worked. So cool. Back to this angular rotation. Let's do our parent rigid body dot rotation is not what I want, is it? Because angular velocity is going to be the velocity. Is there an axis? So I guess, could that work? Could we just multiply this by our matrix? That might work. Let's give that a shot. So we can grab this, and instead of, I said I was going to use the up, we're actually going to use the right, I think, or forward. Let's do forward. So vector3 dot forward. I don't know if this is gonna. I don't know how well this is gonna turn out, but we're gonna try it. So that's our angular rotation, and so that is the rotation amount that we're spinning in every direction. Let's. Does that make sense? Because that's the world rotation, and we have our object location. So let's do a cross product. I'm making this up as I go. I imagine that's pretty obvious at this point. But let's see here. Chunk velocity is equal to the cross product of those two vectors. And so that's going to be our angular rotation. Let's normalize that just because. Otherwise, we'll end up with a longer or shorter thing. Actually, we can normalize the result. That makes more sense because then if we need to normalize one or the other, or if we need to normalize both, it's easier to just normalize it once than to normalize it twice. So let's do that. The angular rotation and our relative subchunk location, and then chunk velocity. Well, actually, we can just add it on there. So get the normalized vector out. And then rigid body dot add force angular rotation. Oh, but since I normalized this, let's take that normalization off. The advantage of doing that is that we should hopefully scale our vector based off of the magnitude of the spin. So the faster something is spinning, we want that vector to be bigger because we want something to go flying off faster if it was spinning fast than if it was spinning slow. And so if we don't normalize things, that should happen automatically. We may need to introduce some sort of like scaling vector here, but I'm not going to do that right now. We're just going to pretend like this works. And then all we need to debug this is something that rigid body spinner. Sure. And so this public float rotation. Let's do vector3 rotation. Start update. Sure. Update. Let's do. This is just a test thing. So this code is going to be really gross. But let's grab our get component of type rigid body like that and do rigid body dot set. We can just do angular velocity, right? Yeah, equals our rotation. And so that should be the rotation being set. And so hopefully this gives us a way to kind of tweak the rotation speeds of our object in real time, and then we can destroy it and see what happens. Probably nothing good. I'm not imagining this is going to work, but I'm just kind of making this up. And if it doesn't work, We may just change directions and do something else because this is like probably not super important. It just seems like if we can get it to work, it'd be really nice. Did that work? I feel like that didn't work. All right. Rigid body spinner. Why can't you be attached? Add component. Rigid body spin. Nope. Cancel. There. Cool. Let's spin it X. Well, it works. That's cool. 0, 0, 0. All right. So that's spinning like that. And so if this does work, we should see them split across the X plane. So the XZ plane, we should see those like 4 rectangles go flying across them. If this works. Or we can see that. There's no errors, so I guess that's good. And everything is rotated correctly, so that's also good. So we didn't we didn't totally destroy it, but it doesn't work. So let's subdivision destruction. Well, we can test this a little bit more without adding a scalar by going up to ludicrous mode and setting this X equals, not that, setting Y equal to 100,000. So that should give us a very strong up vector. And each of these other vectors, so just to kind of like pause this, what's happening here is we have a really high vector going up, and then each of these other vectors is going at some diagonal in the other directions. And so we're taking the cross product of that and getting something perpendicular to that. So effectively we're creating a plane on each of those axes and then getting some extra vector going in another direction. So by increasing this vector, the vector coming off of that plane should increase. And so if we go high enough, theoretically, when we do destroy this, something should happen. Hey, that doesn't look wrong. It's going the wrong direction, but we're like 90% there. So we just need a scalar. Okay, we can do that. Public float destruction scaling. We'll set that equal to 1,000. Maybe a bit high, but that should be fine. All right. That was surprisingly like reassuring. That meant that we weren't totally wrong. All right. So let's try this again and see what ends up happening. Let's move a little bit further back. I imagine when this starts working, things are just going to go flying off. And so I kind of want to be zoomed out just so we have a little bit of a better view of what actually happens. So let's increase this. The way this rotation works is you give it the axes that it spins around. So by setting Y equal to 100 or 1,000, we are telling the Y axis to spin. Oh, that's why nothing's happening. I was modifying the prefab. All right, so this is going to spin that. Didn't see me use it. You were right. I never did use it. You're very correct. We should do that because otherwise this isn't going to work, is it? All right, good call. All right, chunk velocity, get our cross product, add force, chunk velocity times our destruction scaling. Scaling, let's oh, that's not right. What's the rename? F2. Destruction scaling force. Cool. I keep trying to use the resharper command from Visual Studio to do things in Visual Studio Code, and they're not the same. They don't work. That's why those kind of things happen. All right, so now we're actually using this just to make sure. Yeah, the rename worked. Cool. And I think I accidentally, we're going to call it on purpose, but I accidentally added a spinner onto the prefab. So we don't actually need to keep doing that manually now. And we can just take it off afterwards. So we have the sphere. Detonate that. Perfect. And now things go spinning off into along that axis. And so we can spin things, hopefully, and actually have it like make sense of what's supposed to happen. And this should work in any direction. So if we do something like this, this might have some weird effects, but we should see it kind of go in the direction of things rotating. I guess this is probably a good test because it's kind of perpendicular to, or like at a weird angle to what it would be. But yeah, that's about what I would expect. And so things get thrown in the direction they're facing. So actually the rotation is sort of applied and turned into a velocity of the shattered pieces. So they actually break in like an intelligent way, and it just because of the way they break, it actually kind of makes sense. That's cool. All right, cool. I had no plans to do that, but it just kind of popped into my head, and we're like, I guess cross product work. Cool. Well, I'm glad that worked. All right, what's next? We have destruction. We have physics. Yeah, I don't know. Huh, that's kind of neat. I think we're kind of done with this. We can have it like drop some things, I guess. We can have some sort of drops. But really, I think that's most of what I want. So let's create something that will just kind of spawn things, just so we have like a play environment. Because right now, the way this works is we spawn one thing from this game controller, the asteroid spawn controller, spawns a default asteroid. That's not great because this is the same thing that's actually controlling like what prefab to use to do things. And so it shouldn't be doing both of those. So what I want to do is get rid of this and then invoke this spawn chunk thing to spawn a number of them in some sort of random sphere around the player. And then let's say two things. We'll add something so if an asteroid gets too far away, it gets deleted. And if there are not enough asteroids inside of the sphere, we will spawn one inside the sphere somewhere, probably around some sort of edge. So let's create that. So this will be our world controller. And so if we do this correctly, what we're going to end up with is an infinite playing field in every direction. Not exactly what I want for the final game. What I'm hoping to get is some sort of planet ring. So just an asteroid belt around some sort of planet. And so you can just kind of constantly go around that belt. In this case, it's just going to be a perpetual field in every direction, which should be fine for this. And we should be able to use a lot of what we're doing here for that ring. So let's not call it the world controller. That's a terrible name. Let's call it the world. Also a terrible name, but that's better. Cube spawner. Yeah, sure. No. Let's do something with spheres. Spheres make way more sense. Because then everything's just uniform and it just makes more sense. So sphere asteroid spawner. So the way this is going to work, public float, that's not right, public transform of our tracked object. So that's probably going to end up being the player. That's going to be the end goal here, is to have some sort of tracked player object. And then we have our start and our update. We are going to want to track our asteroid spawn controller because that's sort of what's spawning things in the first place, and we don't want to constantly be looking things up. So let's do the asteroid spawner. That is very clever. I like that. So let's do private asteroid spawn controller. So that's just going to grab us what this is doing. There we go. And we can grab that in the start. So controller equals get component, not get component, equals find object of type asteroid spawn controller. And so this will grab our asteroid spawner and just let us use it. If that's null, if controller is null, we want to log some sort of error just so we know things are horribly broken and this isn't going to work. So log error, could not detect asteroid spawn controller in scene. Sure. That makes sense. And now that we have that, hopefully, we just need 2 circles. So float of our spawn radius and public float of our despawn radius. And so the way this is going to work is we need our spawn radius to be less than our despawn radius. Because our asteroids are going to spawn at the spawn radius and despawn if they ever get further away than the despawn radius from the tracked object. And so that's kind of I guess we'll see. But yeah, it just doesn't make sense if the spawn radius is greater, because then we're spawning things and then immediately despawning them and everything will just break. So for the first spawn, I think we want to use inside the unit sphere multiplied by the spawn radius, but for actually spawning after that, we want to use on the unit sphere. So that things spawn, so you don't have things spawning on top of you, because that doesn't seem fun at all, and it seems kind of broken. So we're gonna try to avoid that. So update, that will do our checks. Void on draw gizmos. Let's do gizmos color equals color.red. Sorry in advance for, well, I guess we can use blue as the other color. I was going to use red and green as sort of our spawn and our despawn, but if you're red-green colorblind, you're not going to be able to tell the difference. So let's use red and blue, because hopefully that's a little bit nicer. Draw wire sphere. At our tracked object with our spawn or despawn radius and our tracked object dot spawn radius. Cool. This needs to be the position for each of these. There we go. And yeah, I think that does the gizmo stuff, that does everything else. And public int minimum asteroid count. That needs to be something greater than 0. We're not going to worry about that right now, but that's going to determine the initial number of spawned asteroids, and then also the I don't actually know, but also it's going to determine if anything falls below that, we're going to actually loop until we get above it and spawn things in the spawn radius. I think that makes sense. Unity does have more robust gizmos. There is this thing called handles. Unity editor.handles. And you can draw arrows and all sorts of things. They work a little bit differently, but like if you look at like the rotation controller, for example, so if like I select something, this is drawn using handles. It's not drawn using gizmos. And the advantage of this is you can actually like manipulate things a little bit more. But because you can actually interact with handles and you can't interact with gizmos, they're just a little bit harder to use. So for debugging, I prefer gizmos, and for like editor tools, I use handles, if that helps. I'm not going to go into that here because that's a little bit off topic, but it does exist, and if you want, you can go and check out some of the docs on that. It can be a little bit confusing to get started. It took me a while, but yeah. So there's that. Let's see. Draw sphere, all of this, update, start. Spawn initial asteroids. Actually, we can do something cooler. Let's use a lambda, because why not? And we'll do spawn asteroids, and we're going to give this a function for where to spawn them. And so what this is going to do is look something like this. So given an empty parameter, we are going to return a random dot on unit sphere. And so the advantage of this is on unit sphere is not evaluated until that function is invoked, which means we can invoke it multiple times. But then when we're doing our update, or we can use on unit sphere in our update to spawn new asteroids as they get outside. But on the other side, when we're doing this random inside unit sphere, we can do that to sort of initialize everything. And this way we can use the same code without having to have two different implementations for the initial spawn and then the secondary spawn. We can just use different random functions for positioning. I think that makes sense. Yeah, let's do that. And then hopefully when we generate a method, we get this. So the function of vector3 rotation func. Sure. And then that just gives us a way to actually randomly generate those. Cool. I think this makes sense. I hadn't really planned on doing it that way, but it works, or it should work. And we just imported system because we used func. So let's do unit, well, no, let's do system.func and remove that import there. There. Hopefully that keeps things cleaner. And then we'll just return for now from that. So that doesn't do anything, but it does work, or it does something. So we have this game controller. Let's attach our sphere asteroid spawner there, move it up, and set the spawn radius equal to 100. Oh, we don't have a tracked object, so let's track our main camera. There we go. We're going to want to change that blue. That's really hard to see. And then a despawn radius of like 150 with an asteroid count of 50. That's enough for us to get sort of this experience, but also not enough to like lag anything, I'm hoping. So they should all spawn inside that blue circle, and then when they exit the red circle, they should get destroyed. At least that's the idea here. So I think for this, or while, do we want to do while? I think when we call spawn asteroids, what we want to do is get all of the game objects of a specific of a specific layer layer tag, tag, or with a specific component. Let's do tag. Tag asteroid. Okay, sure. And so we want to tag our cube as an asteroid. And so what we can do is get the count. Yellow. Yellow would work. Cool. All right, we'll use yellow. Something brighter. Yellow in Unity is weird because it's the only color. Oh, it doesn't show it here. Let's see. Color yellow. If you haven't seen this, the documentation for yellow is yellow RGB is 1092, 0.016, and 1. This is the only color in Unity's default colors that isn't maxed in every direction. So if this was adhering to the normal pattern, it would be 110, like everything else, except that isn't what happened. For whatever reason, whoever implemented this decided to use some nicer version of yellow, and it's just weird. Yeah. So anyway, there's trivia on the color yellow. Why not? There we go. And so we are going to. What we need is the count of the number of asteroids. So game object dot find game objects with tag, and we want to get asteroids. Asteroid. I've already forgotten the name of the tag. Well, that's not asteroid. Okay, cool. We should probably have that be a parameter. I'm going to hard code it for now because I'll probably come back to this code later to update it. But for now, this is fine. So we're going to grab all of our asteroids like that and set that. And what this lets us do is get the count. Asteroid number equal asteroids dot count length. There we go. And so now we can do for int for nothing while the asteroid. Let's do this. Let's put this in the for loop. Take it out of here and say, while the asteroid number is less than the minimum asteroid count, increase the asteroid number by 1 every loop and spawn an asteroid as part of this. And so what we need is some sort of rotation, a scale, and something else. And so that's going to look like our controller.spawn chunk at a position. And the way this can work is we can invoke our rotation function to get our rotation function. Why did we call it that? Position function. Position func there. And so that will get us our position. We can multiply it by the spawn radius. And so that should hopefully get us a place to spawn new things. And then, what are we doing? 1. We're just going to, well, that can actually stay. Because it's checking the number, this shouldn't cause things to constantly be spawned. It will just be slow. That's fine for now. Spawn chunk, that gets us our position. Our next thing is our rotation, which we can just do a random rotation. Just give it something random. It doesn't particularly matter. We don't really care. And then the size is going to be one of any number between 1, 2, 4, or 8, which we can get by doing math.pow math.pow. Why doesn't that work? Okay. We can do this a different way. We can do 1 bit shifted to the right by random.range of 0 and 3. Sure, that works. And so it's doing bit manipulation, but what this is doing is effectively taking powers of 2, because we're just bit shifting that 1 across. And so it'll be 1 and then 1 0, which is 2, and then 1 0 0, which is 4, and then 1 0 0 0, which is 8. And so the number of bits we shift is equal to this. And effectively what this is saying is the random range is the number of zeros after the 1 in the binary. That's probably not the best way to do this. mathf.pow. Oh, well, that would have been easier. No, we're just going to keep it. Sure, it's fine. So I can actually go into this a little bit more. So what this ends up looking like in binary when I write this is you get a bunch of zeros. Let's do 2 bytes. So that looks like this. So this is 1. This is the integer 1 in a byte. Depending on what you're doing. For our purposes, this is 1. When we bit shift to the right, what I'm doing is moving that over 1. And so this is equal to 2. And so if I do this again, we end up with this, which is equal to 4. And so this is just doing binary shifting, effectively. Just bit shifting things over. And now that I'm thinking about this, I think I want to left shift. Pretty sure. Probably did this wrong. But effectively, if you want powers of 2, you can get them by bit shifting 1, the number of powers you want. Because effectively, 1 is equal to 2 to the 0th power. So 2 to the 0th power is just equal to 1, because anything to the 0th power is equal to 1. And then 2 to the 1st power is, or anything to the 1st power is equal to itself. So 2 to the 1st power is equal to 1. 2 to the 2nd power is equal to 4, and so on. And that's sort of how any number system works. So if we were talking about like decimal systems, if we write 1, 1 is equal to 1, or 10, sorry, to the 0th power. So 10 to the 0th power equals 1. If we were to write 10, that's equal to 10 to the 1st power itself. And then 100 is equal to 10 to the 2nd power. And so the number systems work exactly the same. The only difference here is we're doing base 2 instead of base 10. And that works really well because we're subdividing things. And so we want to cut things in half every time. And so because of doing all of this, the way this ends up working is we can use this math in order to generate our fun little code. But I'm pretty sure we want to move the bits to the left, which means we need the other type of shift. Hopefully that makes sense. If it doesn't, maybe I'll have to do something more on binary math. There's also a really fun book called The Hacker's Delight. The first chapter is free. Hacker's Delight. This book is super cool. It's pretty much just some, I think, IBM engineers book on how to do bit manipulations, and it goes like super in depth into like things you don't ever need to know, but is just kind of cool. So if you really like low level system stuff, this book is cool. The second chapter, which is like basic bit manipulation stuff, I'm not going to go into it, is free on the website, just hackersdelight.org. Or you can just buy the book, which it's pretty. It's not one of those books that you're going to read cover to cover because your head will hurt. But it is kind of fun to just kind of glance at occasionally, or just like pull trivia from. So anyway, that's enough on bit stuff. Yeah, but hopefully it doesn't like what we did. Is that, no, okay, that's just old errors. Let's do this. If our tracked object is null, then let's return. That will just prevent this from throwing errors in the future when our tracked object doesn't exist. But yeah, hopefully we can run this and get 50 asteroids. Yes, awesome. And they're all going to be rotating on their axis because we have that rotation controller applied to them. They're not going to move though because we don't have anything there. Also, that one spawned right at the 0, 0. Was that already there? No. How did we get... Okay. Apparently we got one to spawn right at this origin. I may have screwed something up and caused that to happen. That shouldn't happen. Oh, that's what's causing it. This asteroid spawn controller still has this. So we can copy that out. That doesn't need to be there anymore. It shouldn't break anything. Yeah. But now, hopefully, we can destroy things. Or not. Why doesn't that work? Okay. What? Oh, when I recompiled things, it recompiles the library of all of that code, which means that our object assignments, the links that we had set up, are gone. So, in order to test this, I think we're going to need to grab an object and move it to 0, 0, 0. What size are these? Are these all? No, that's 2. That's 4. Cool. So we are getting those random sizes. That one looks like a 1. Yep. Neat. Not 2. It's just because it's closer. Yeah, I think this is working. I don't think that 3 was inclusive, and so in our range, we didn't get anything really big. So size, where was it? The asteroid spawner. We want this to be inclusive of that 4th because we want it to be 0 or 1, 2, 4, or 8, which means it can be 0, 1, 2, or 3. The right-hand number is not inclusive, which means that it's not included. It can't possibly come out of the random function. And so what this range is going to do is go anywhere between min and max -1 because it's integers. And so that's why we never got a size of 8. All right. So hopefully we get a whole bunch more asteroids, some bigger ones now. 4, 8. All right, good. And so if I move this into here, I should be able to blow it up. This. Oh. That was very fast. That shouldn't have been that fast. So let's try scaling this down a bit. Destruction scaling force 100. Just guessing there, but let's try that. There we go. So those go flying out and they might hit something. We'll see. But I think the actual solution to our problem is, 1, we don't have any despawning. So these will keep going forever. That needs to get fixed. But also, nothing spawns with any velocity. And the rotation is always a constant, which isn't good either. So we're probably going to want to fix both of those. And I think we can do that inside of this asteroid spawn controller. That's not the right thing. Sphere asteroid spawner. There we go. And so this is doing something and returning var asteroid equals the spawned asteroid that we created. And then what we want, one, is to delete this entire script. So we have our rigid body spinner. I'm just going to delete that. We don't need it here anymore. And so, and save our scene. All of our objects should be cleaned up. And then let's go in here, grab the rigid body equals our asteroid.getComponent rigid body. If rigid body is not null, let's assign some sort of random rotation and random velocity. So rigid body add force, or we can just set the velocity actually. So adding force is different than setting the velocity, because force is going to be modified by the mass of the object. But if you just set the velocity has already taken into account the mass. So it's not going to be modified by that. So a higher mass object will move less than a lower mass object when the same force is applied to it. But if we set the velocity, both of those objects will move the same speed. And that's what I want. So rigid body.velocity equals a random.inside unit sphere. This will just get us some sort of random vector inside of that's either has a length of 1 or below. And then we'll do our max rigid body spawn velocity. Sure. That doesn't exist yet, but that's fine. And then our angular velocity is the rotation amount that we're actually using. And we can use that inside unit sphere value again. But we're going to do max rigid body spawn rotate or angular velocity. And yeah, that gets added onto our thing. We want these to be floats. I don't know why it created vectors. Probably because I told it to, but there we go. So max rigid body spawn angular velocity and our spawn velocity should mean that we can actually apply these to these objects. So they'll actually all start moving if we've done this correctly. And so those should pop up shortly, or not. Are they not public? They're private. Okay, that's what's going on. So private variables don't show up in Unity's inspector unless you force them to. But I'm going to make them public because that just makes way more sense. So we have our spawn velocity. This will be meters per second, effectively. Units per second, I guess, but the maximum units per second that the object will move. I'm going to set it to 5. Sort of guessing here, but I think 5 makes sense. And then for our angular velocity, let's set that to 10. That might be really, really quick. Because I believe that will be translated to degrees per second on every axis. So it could be rotate a maximum of 10 degrees per second, which, yeah, looks way too fast. So let's set that lower to like 4. This is more like a guessing game, just to kind of get it correct. But you can see everything is now moving inside of this. And some of it is already drifting towards that outside edge. And so like this object now would ideally get destroyed. And we can actually manually do that. Actually, we should be able to select most of these And if I destroy all of these, more should get created in their place. And that is interesting. We get a whole bunch of the same value in some cases for our position, it looked like. Actually, no. What happened is we destroyed objects larger than a thing. Larger than a 1 by 1. Okay. Alright, so what I'm trying to test is I should be able to delete a bunch of these. And more should get created along the outside border. So if I delete every cube, we get 50 more. And so that means that our respawning logic is working because they're spawning on the edge with their extra velocities and things, and then moving from there. So that's good. That means everything is working there. The only thing that isn't working is despawning. And since everything actually gets spawned inside of the here, is there a way we can be smart and track all of them? We don't track destructions, unfortunately. But we might be able to. So what we could do is attach something extra onto this onDestroy event that tracks when things are destroyed and removes it from some sort of list. The problem with that is it doesn't track all the new objects that get created when we hit here, when we blow this up. So all of these new chunks aren't going to get tracked. And that might be a problem. So I think for now, until we can come up with something better, in our update, we are going to do this is bad, git component. We're going to do more link. So we're going to do a game object dot find game objects with tag asteroid. And we've used this constant twice now. So I'm going to pull this out and do public string tracked asteroid tag. And this way, we have that just tracked in a more reasonable way. When we start adding these hard-coded strings everywhere, it gets really hard to follow them. And so this hopefully will give us a better way to deal with that. So yeah, that's the motivation there. But by doing this, we'll get all of the game objects with that tag. We can pull them out and do select. I can't really, so what I want to do is filter all of these based on their distance, the magnitude of their distance, and the difference between that and the player's location. And so where we don't have link, that's going to be important. So using system.link, we can pull in that and use this where to filter out all of the objects with a radius or with a magnitude greater than the radius. Yeah, so this shouldn't be done in the update. This is bad. We're gonna do this to get this working, and then we can come back to it later and make it better. But right now I don't have all the other like architectural components in place to make this work easily and nicely in a different way. I think what we're going to want is some sort of event that triggers when an asteroid is spawned, so we can track that, and one that triggers when an asteroid is deleted. Like some sort of global event. And we don't have those right now. And since we don't have those, we're going to cheat, and then we'll come back to it. So that's sort of my plan. That we can actually probably do that next. But the goal here is to get this working first, just so that we have like a working example of what we want, And then we know that that's actually what the behavior we want. Because if we spend all that time like architecting this really complex thing, we might. Yeah, the videos should be archived, and so you should be able to find it. They are a little bit weird sometimes to find. Like live streams don't show up, and I know like the API doesn't return them. So like the personal like worldofzero.com website doesn't actually show live stream videos, and I haven't really figured out why yet. But I'll look into that. But yeah, they will show up on the channel itself, so you can definitely come back. Yeah. Thanks for joining in. That was fun. And good suggestions, by the way. So, where... And well, this is going to get a little bit complicated. Bye. All right, so we want to calculate the position of the object, subtract it from our tracked object's position. So asteroid dot transform dot position minus our tracked object dot transform dot position. We want to get the magnitude of this dot magnitude, and then find all the versions or all of the asteroids that have a magnitude greater than the despawn radius. And we don't need those. There we go. Which means at the end of this, every asteroid that is still a part of this string, a part of this stream, is going to be outside of our despawn radius, so that we can delete them. And so we can do our toList.to for each. This is gross, but that's fine. Again, temporary stuff, so it's temporary. So what we want to do is, I think, just destroy them, because they're outside of the spawn radius, so we can just get rid of them entirely. We don't need to invoke the subdividing destruction thing, because that will just spawn more asteroids that are outside of range, and so we don't want that. And we don't want to subdivide things just because they get outside of the range, because that doesn't actually make any sense. They're just getting destroyed when they shouldn't be. So we wanted to destroy, for each asteroid, sorry, we want to destroy the asteroid.game object. I don't think the game object part is required there, because the asteroid should already be the game object. I tend to do this more to safeguard myself. If I ever refactor this code, an asteroid becomes like a component of it or something, this destroy will just destroy that component instead of the game object. By adding the game object, if we replace this with a model behavior, it will still get caught and get deleted. And so it's a little bit, I feel like it's a little bit safer. I don't know if it actually is it at all, but hopefully that works. And so, oops, let's restart this. Let's increase the number of asteroids we spawn, just so we'll see more of this behavior happening. And let's also increase the velocity so there's more chaos. Set it to 20, I guess. And so hopefully we'll just see a whole massive explosion of things. And so that asteroid should get deleted. Yeah. So we can see things going away, and also new things popping in around that inner yellow sphere. So that means our destruction is actually like clamping things, and it should mean that I can take this camera and move it, and we will get more objects. We don't, because my spawn is incorrect. Okay. That makes sense. So we moved outside, but because this is wrong, our position func times our spawn radius is not actually where we want to spawn things. Where we want to spawn things is at our tracked object plus whatever that was. And so this function was spawning them at the origin, which means when we moved it, everything was still spawning there and then immediately getting despawned. And we don't want that. So we'll do plus and then what we had previously, which should mean we can now move this correctly without despawning everything. Tracked object.position. There we go. Cool. And then hopefully we can start this. And we get everything spawning there. And now I can take the camera and shift it to the left. And it seems like our game space is sort of shifting as well. A little bit laggy when you do it really fast because we're effectively destroying everything and recreating it every frame, which isn't great. But the handy thing here is it means that you can just kind of keep moving and keep playing. And we can expand this further so it doesn't feel as claustrophobic. But hopefully that keeps like a consistent play or playing experience perpetually. And you just never run out of things. So yeah, I think this makes sense. We now have a way to perpetually get new things. So let's increase this sphere and cause massive amounts of havoc. Massive amounts of havoc. There we go. And subdivide everything. That looks cool. And so we've destroyed everything. We can optimize this a little bit more by using something like an object queue. And so that will keep one of the slowest things in Unity is creating new objects. And one of the ways you can speed that up is by storing a bunch of created objects and just disabling them. So they're not actually doing anything. They're not really behaving in the scene. But all of the things to initialize them and put them in the scene have already been done. And so instead of actually like destroying things, we can just remove them and add them back onto that queue. And then as long as we don't exhaust that queue, we should be good. And that will take a lot of the slowness out of this. We can do that later though. That's more of an optimization, so we won't really worry about that. But yeah, I think that's most of the destruction stuff. We can lag it again. Does that actually cause any like streaming issues? Doesn't seem to. Just lags Unity. All right, cool. So there is a massive amount of shrapnel and things going on. That is a very slow explosion. That's cool. I really like that spinning destruction thing we just built. That was really fun. I'm really happy that worked. Yeah. So the next thing, we had talked about tracking, like a global tracker for asteroids that are created and asteroids that are deleted. Let's build that because right now I don't have anything to track those. And at least for this, right now we're tracking everything in the update. And we're doing that by actually finding or telling Unity to go and find everything with the tag. And that's just not great. So hopefully what we can do is actually swap this in with something that perpetually already has that list and just maintains it itself. And I think that will make a lot more sense. We probably won't maintain the list of asteroids in this object. We'll maintain it somewhere else. But I think having something that can control the number of created asteroids will just make our life a lot easier. So let's do that. I don't really know what this is going to look like, but let's put that in the world and call it our Asteroid Global Tracker. Yeah, sure. Why not? Yeah. And so what we need to decide is how we're going to store these. A list, I guess. A list kind of works. And maybe that's the best. I'm trying to think if there's something else. Hold on. So what I would like, well, No, let's not do that. I think a linked list might be our best starting point. So I'm considering things like a map or an array or a list, which is just an array list, or a list. If we use a map, we have like constant time lookups, which means just specific objects are really easy to find. And so the best case there is like if we have like an ID of specific objects that we know, and we need to find them in this list, we can find them really quickly. But that ID can't change, so we can't use like the position. It would have to be some like constant value. And I don't know if that's actually very useful in our use case. If we use an array, what we're going to run into is we need to deal somehow with the null values that get added in. And we also have to worry about like resizing our list to make it bigger or smaller, or probably just bigger, if we add more asteroids. And so that might be a little bit of an annoyance. If we use an array list, that resizing goes away and we don't really have to worry about that anymore. But it's still an array. And so we have all of those shifting things when we add and remove things. And so there's overhead there. Whereas if we use a linked list, finding things like specifically indexing into specific objects is harder, and will be a little bit slower. But inserting and deleting is faster. And I think that's what we want. Because I think that just makes the most sense. So we're going to do a game object here or a linked list of game objects. And so this will be our asteroids. And what else do we want? We want a unity event. Of asteroid create and asteroid delete. I think those are the two events we care about right now. So when something is created and when something is deleted. And so how did we do this in our health tracker? Okay, we just had to add that. Okay, sure, fine. Public unity event of type on asteroid create and public unity event on asteroid delete. But I don't think this is going to work because we need some sort of game object event. Actually, let's just try this. So game object, put that there. And put that there. That might work, or it might not. Unity events can be a little bit finicky as far as this is concerned. And so we might need to create our own Unity event subclass, but hopefully we don't, and we can just avoid that. And I'm hoping by using game objects, we can avoid that. And so this is just going to pass in the game object that is created or deleted. And something's going to have to be in charge of doing this. Luckily, we have our asteroid swan controller that can kind of centralize a lot of the creation of objects, and our destruction thing that can centralize a lot of the destruction of things. We might want to move this, like we have destroys. I don't know if we want to try to trigger on that. There is a function called onDestroy or something like that. And this is a unity function, if I'm remembering, that gets called when an object is deleted or will be destroyed. And so we should be able to use that instead and have some sort of extra mono behavior attached that automatically catches that behavior without having to worry about anything else. And so that object may actually just be able to handle both the creation and the deletion. And so that particular part doesn't ever need to be handled by any other mono behavior anywhere. And it can all just be, the life cycle can be handled by those two classes and nothing else. Hopefully that works, because that will be really nice. All right. We have our linked list. Let's do private linked list. That's going to be private because I don't want to expose the linked list to anything else. Instead, we are going to have a public IEnumerable of game objects. IEnumerable is just an object type that can be enumerated over. So if you have like a set of numbers or something like that, that's something that can be enumerated. So 1, 2, 3, 4 would be like positive integers. But you can't like look at the underlying structure of how those are organized because it's just a list, a series of specific things. So the only option you have is to iterate over it, not necessarily to like dive into the specific types. And so I think that's nicer because the advantage of doing this is we aren't exposing that we're using a linked list to everything else. And so by doing that, we're preventing those other classes from relying on us using a linked list, which means if I ever want to change this, I can pull it out later and not break like all of my code. Because we're using this interface, we avoid some of that. So that's the motivation there. That's why you would want to do this. If you don't care about that, then don't do this because it's just an extra level of abstraction that you don't need otherwise. And we can use the fun lookup thing and just return this. And so this is just, if you give a lambda expression to your properties, it creates a get property that just returns the right-hand side. In this case, a linked list and most other lists or anything is going to already implement this interface. And so we don't actually need to do anything. We're returning the actual type. We're not casting it. We're not doing anything else. We're just restricting the amount of visibility the other people can, or the other classes can see into what we're doing. So yeah, there's that. That's exposing that. Cool. And then on asteroid create, we want to pass something in. On asteroid delete, we want to do that. And so I think all we need is a awake method that is going to do on asteroid create. We are going to take our game object and add it to our linked list. So asteroids.add last. Also, I misspoke earlier. I said that deletes in a linked list were constant. We don't have to shift, but we do have to find the object we're deleting. So those are going to be O of n time. Just not thinking about that. So we're just going to add the game object to it, like so. Cannot be used like a method. Oh, dot add listener. There we go. So when a new asteroid is created, we have this listening to that, and it's going to add it to this list of asteroids. And then the other option is when an asteroid is destroyed or deleted. Let's call it destroy. On asteroid, that's not right. Destroy. We are going to add in the option to remove it. Remove that. And so both of these will just take the game object in that we're working on and either add it to the list or remove it. And so that should hopefully keep all of these up to date, assuming we're doing this. The side effect of this is there is no safeguards about putting anything else into here. So you could throw like the player into this list. There's nothing that's going to stop you because it's just game objects. But don't do that. We're not going to do that. We might be able to add some extra safeguards here to prevent that, but I haven't yet. And so that's just something we need to be aware of. So those null checks are going to be kind of required. Asteroids, we need to initialize our list because we haven't yet. So I'm just going to create an empty linked list and we're good. And so that should be our global tracker for asteroids. And then we need some object. Asteroid lifecycle controller. I don't know why I add controller to everything. I say that all the time. But it's some habit I got into when I was working a lot with like model view controller stuff. And so things that do this kind of thing, I just call controllers. And yeah, not sure if it's a great pattern to or great habit to be in, but it's where I am, so that's what we're doing. There's an on destroy, right? Let's try that. Debug.log destroyed. I don't know if this function exists, so we're just going to log for now, just to make sure that it does happen. And created. We're going to do that in the start. Does start make sense? I think so. We'll try it. Because that means hopefully things will have been initialized by the time they're consumed. And so I hope that leaves us good. If we do an awake, it might be too soon, is what I'm concerned about. Hello. Start on destroy. We can try those. We should see in chat or in the console now when things happen. So the first thing we need is this asteroid global tracker to be attached here. We're not actually consuming that yet. We're not really doing anything with that yet. And I imagine our events are broken because we don't see them here. And so because we don't see them, it's a good indicator that that game object event isn't working. So we can explore that in a bit. Let's do our cube, go back, lock that, go to our world and add the lifecycle controller on the cube. What? Open prefab. There we go. Let's unlock that and remove that unlisted script. Lifecycle controller will attach that. There we go. And so now all of our cubes should have that attached to them, which means I should be able to create this and then have it spam in chat. A bunch of things were created. Ooh, that's not right. Let's collapse these. And we are getting destroyed events, which is good. It means that things are getting destroyed and we're actually seeing those messages get triggered. And it looks like we have 100 more created than we have destroyed. And there should be 100 asteroids, which means that everything is staying in sync, which is also good. So that gives me enough confidence to say that that's working-ish, which means the next step. Ooh. Global tracker. I'm really tempted to turn this into a singleton. And so what a singleton is an object where there can only be one of them. But if we do that, static objects just get annoying. And they're just really hard. Like when you start like switching scenes, you have to remember to deinitialize your static stuff because it's going to stick around. And in this case, we're going to try to bring game object references across a scene boundary if that happens. And that seems like a really bad idea. So I would like to not do that. So I think, what's the best solution to that? Lifecycle controller. Maybe in the lifecycle controller. No, because then we still have the static reference. But that might become null if we switch scenes. So let's try that. Let's do a private static asteroid global tracker. And so the reason I want this to be static is because otherwise every time we spawn an asteroid, we're going to have to go and find this asteroid global tracker, which can be really slow, and I don't want to do that. Instead, what I would prefer is if we were able to just constantly have that reference, and so we could create these objects more easily without having to worry about that. But if we use a pool, if we use a game object pool, that isn't a problem anymore. So let's not worry about it, right? Because if we're storing all these objects and doing all of the heavy lifting at first, we don't have to worry because we will have already initialized all of them. And so we don't need to keep a static reference. Actually, I was wrong. Okay, cool. Well, that makes that easier. Asteroid global tracker equals our tracker. The downside of that is this isn't going to be very performant until we get that global tracker in. So for now, we just need to do tracker equals game object, find game object, find component, find object of type. There we go. The asteroid global tracker, which is not a great way to do this, but it is the way we're going to do it. And then you can do tracker dot on asteroid create dot invoke. I don't really want to do it like this. I don't want objects that aren't the event owner to be invoking events. So let's do asteroid created this dot game object. I think that makes more sense. And then we can have an asteroid deleted, asteroid destroyed, asteroid destroyed. We'll pass in the game object again. That seems safer to me. Whoa, wrong button. All right. Generate that and generate that. And there are two functions. We can go down here. I don't want to use an internal method, so we're going to do public again. Maybe making the scope too big, but that's fine. And we'll call these the asteroids. And then all this is going to do is invoke the function or invoke the event. So on asteroid create dot invoke. Again, we're doing the null check just to make sure that it has something attached. Theoretically, because our awake adds a listener, that should always happen. We should always have something listening to this event. But that may break. I don't know. And so this will just catch that and then not do that if things happen. Do I want it to break? We should have a check. This doesn't seem safe. So on asteroid create is not null. It's a little bit more code, but it should be a little bit safer because this means we can actually log if our event is uninitialized. And that is something we're going to want to know because that means something very wrong is happening. Like the entire game lifecycle will not work because we're basing everything off of these events. And if these events aren't initialized, nothing's listening to them. And that means bad things are happening. Asteroid create event is not initialized. And so hopefully that just gives us a little bit of warning and says something awful is happening. And we need to do something about this. But otherwise we can just invoke it by passing in our asteroid and giving it a semicolon. There we go. And we can do the same thing, more or less, for our destroy. The function, I guess, or the event is identical. The only difference is what the listeners are looking at, and when they trigger. So you can plug those in. Asteroid destroy event is not initialized. I don't think adding the game object into the log makes sense. So we're not going to do that yet. But I may change my mind. If that becomes something that I care about, we'll add that back. On destroy, it's called there, which means asteroid global tracker. We have this public int size. And so this is just going to be for debugging purposes. And the idea here is void update. This is entirely for debugging. We're not going to keep this code, but I just want it so that I can see that the list is growing and shrinking. And it should be identical to the number of asteroids that exist. So we should see 100 for size, which is going to be equal to the asteroids.length. .count. Right. That's going to be slow because it's a linked list, so we're actually going to have to like count things. But again, just for testing, so shouldn't matter too much. So let's run this. Create event is not initialized. Ooh. Well, that's no good. Is not null. We want to invoke that. Otherwise, okay, so what's happening here is we are doing Unity events wrong. And so what we need is a public class Unity game object event, which extends a Unity event of type game object. Like that. And I think that's all we need. We just need the Unity, for whatever reason, struggles a lot with generics. So it can't really handle them. We don't need those. And so because of that, you need a custom class that defines the generic. So effectively, we've created this class which just hard codes the generic value into that, which means that anytime we see a Unity game object event, we're just saying that's a Unity event with a generic type of game object. And that makes Unity able to understand what we're talking about, which should mean that in our inspector now, we will see nothing. Why don't we see anything? Okay, well, I was wrong. I was expecting to see 2 events listed there. It's still broken. What did I do? I broke it. Unity base event? How have I done this in the past? That would be a great thing to know, because we've done this in the past. Unity event. Let's Unity event. Unity event. The constructor. Thanks. We need to make it serializable. So if we mark this as a serializable event, it means that C# can actually serialize it and sets up all the stuff that we need to be able to do. Whoa. Not that. There we go. And so that will make it serializable. I imagine that's why Unity doesn't like generics, is because they're harder to save. And now we know that this is working because we get these 2 things, which is Unity's like UI implementation of being able to see this. So if you can see this, that's a good sign. It means that Unity actually knows what you're talking about. But you need to do that in order for it to work. One weird thing, Unity has no representation for things that are set up for events, for these events that are set up inside of code. So when we do this, when we run this, we have things that attach to these events and fire them, but they don't show up there, so we can't see them. Our size is staying at 100 though, which is good. That means that we have things still existing around. It does drop to 99 occasionally. I imagine that's because there's like one frame or something where it's getting deleted, and then the next frame it gets created. But yeah, I think that's good. It's good enough for me. So we need to now access this asteroids function from a few other places in order to actually handle the lifecycle. Not the lifecycle, to handle the creation of new things. Because previously, every frame we're looking up all of the asteroids. Now we have this list of asteroids. So we don't actually need to do that. And so when we're doing overlap sphere, that's not right. Again, nope, that's not right. Spawn controller, nope, that's not right. Sphere, the sphere asteroid spawner. So this, right now, is going and getting all of our objects with a tag of our asteroid and then doing something with them. We don't want that. Instead, let's store a private asteroid global tracker. And so we'll just grab our tracker and do tracker equals find object of type asteroid global tracker. That grabs the tracker, and then with that we can swap out this line and do tracker.asteroids instead. And so that's going to actually give us a list of all of the existing asteroids, and so we don't need to actually like go and find them all and tell Unity to search over every game object and try to find things with a specific tag, because that's just gross. So we can do that. And we can do this. There is no length function though on our asteroids, and so we're going to use link to count it. Because it's so small, that should be fine. And it will only get called once because it's in the initialization of our for loop. If we were doing count in this section here, that gets called every time we loop, which means in this case, count is not returning a constant value. What that's going to do is actually iterate over every element in our asteroid list and increment a value until we get to the end. And so if we were doing that every for loop, we would effectively be iterating over all of our asteroids twice. And that isn't good. So we would want to avoid that. In this case, that isn't happening, so we're not super concerned about it. And also the value is at most right now 100, which is like nothing, so we don't really care. So I think that should work. And I guess the way to test this is if our asteroids continue to spawn. Because this is how we're detecting despawn. Which means when those asteroids get out of range, they should despawn. And we should still be able to track them. So as this continues to go on, even the new asteroid should fall out of the range and then be detected and despawned. And as long as that's happening, it means that our asteroids list is staying up to date. If things go way outside, bad things are going to happen. And we can move this around a little bit, kind of subject it to some worse behavior. And actually, performance seems better. And this just gives us a way to kind of force respawning a lot of things really quickly. But because everything seems to be just recreating itself, I think we're good. we're not really running into any major issues. So I'd say that's a win. And our asteroids seem to work. The only thing we haven't tested is if we were to destroy this. And so we destroy that object and get 4 subchunks. Those also need to get destroyed. And so we can destroy that one as well. And so like this should get deleted when it goes outside. Yeah, and it still does. Which that's good because that's a different use case and it's still working. So I think pretty comfortable with this. This is a lot of this code is something we're going to want to like write automated tests for later. Just because right now testing this all manually is easy. When we introduce VR stuff, testing all of this manually is going to be a pain. So we'll have to figure that out. But for now, I think we're in a good spot. And really, I think that's destruction done. Like we have a way to deal damage in a radius, and we have a way to do pretty much everything else. So I think we're to the point where we can play, I want to say. Maybe I'm wrong, but I'm pretty sure, we're good. I could be wrong, but the only other thing that I might want to change, now that I'm thinking about it, is we have this inside unit sphere math here. We might not want this to be exactly like this. Instead, we may want the math to look something like the spawn, well, let's just do this. Spawn radius divided by despawn radius times a random.on unit sphere. And so what this is going to do is give us a buffer. If I'm thinking of the math correctly, what I'm trying to do is introduce a buffer around the player. So there isn't anything that's going to like spawn immediately behind you or like right on top of you. It's going to spawn with a buffer of the difference between these two. At least that's... Why am I doing division? We don't need division for this. We can just do despawn... Oh, I know why. Because we're multiplying this by a spawn radius. And so this will pull out the spawn radius, or this will double the spawn radius. Am I thinking about this right? I think so. Let's see. Let's run this and see if this comes anywhere close. I think the math is right. Yeah. So we don't get anything near the inside. And that's just so like you don't die immediately, because that's lame. And it doesn't need to be perfect. It just needs like some amount of buffer. And then that can go away because everything has a random velocity, so things will actually move into that space over time. We just don't want anything to start there. And so I think that accomplishes that. But yeah. We can destroy this. We don't keep the velocity of the thing. So let's add that as well. So spawn asteroids does all of this. Where subdivision destroyer. This class is getting a little bit gross, but that's kind of expected. Again, this code is going to get gross and then we'll make it better over time. But the grossness is sort of a function of how we're approaching this. And so we add the force here. That is going to be the force for our object. But what I want is not just that, but I want to do dot velocity plus equals the parent rigid body's velocity. And this way, the objects will still be split apart, but they'll all maintain the original parent velocity that they had. So they won't stop and split apart. They'll like continue moving along, but they'll spiral apart from that point. And I think that makes more sense. I guess we'll find out. But there's a lot of janky things going on. So that if we destroy this, yeah, that looks a little bit more like what I want. Where things kind of, you see how they like spiral away still, but they continue along that original trajectory. I think that looks a little bit better. It's not like we're creating something new. It looks a little bit more uniform, I guess is the best word for it. There we go. Yeah, no, I think that works. Everything's still a cube, so it's kind of not not super nice, but I mean it's nicer than what we had. So yeah, and I don't know. I think the destruction actually works for how primitive it is. We've actually got like a good system going. I think it's actually working quite well. So what's next? Movement? Do we want to get into movement? Like I've been streaming for what, like 2.5 hours? We could do movement. That probably will take a while. Movement is the hardest part of this. I was demoing earlier in the stream how movement has worked in the past, and I'd like to get back to that. But to add movement, it means we also need to introduce VR, which means we have to start like working with this. And that gets more complicated. Not so much because like it's hard. Effectively, all we're doing is we're getting a few different things to track. The hard thing is that now we have like this external devices that we need to actually manipulate to test things, and that's just more difficult. So is there anything else that we should do in the meantime before we jump into that? I don't think so. The only thing that I could think we might want to try, does this make sense? Yeah, the only thing I can think that we might want to try is scaling things and having a texture that looks a little bit nicer than a gray matte cube. Like I can go into here and attach a material. Do I even lightweight render pipeline lit? Sure, that sounds fine. Let's grab a base map. Sure. Ground. Something that isn't like super dark. This is the only thing with color that I have in this project right now, because they're just like the default Unity materials. So we're kind of limited, but that should be fine. Metallic map and a normal map. Nope, that's not going to work. Just trying to get everything somewhat set up. So like a particle board, I think that's what that is. So let's apply that to our cube. And I can kind of show what the problem with this is. Because I think there's going to be a problem. Let's set the velocity to 10, just a little bit slower. When things come at you really fast in this, I want it to be something, a result of something you've done rather than a result of the start of the game, because it's just hard. The problem with this is if I destroy that, the texture gets smaller. And that doesn't really work because it means that like everything changes when you destroy it. And I don't know, that just doesn't really, it's hard to understand that. So I think what I want is to scale this. So let's write a shader. Let's try shader graph. Why not? That should be in here. Right? Yeah. A physically based rendering graph of our scaled material shader. Let's give it a shot. It's been a while, but let's see. So this will be our thing. We get all of that fun stuff. They did add position-based or vertex shaders, so we can actually modify the position, which could be cool because I think that means, can we do tessellation? No. So we can change the vertex coordinates, but we cannot tessellate things yet using shader graph. That's fine. Can I get the scale? I don't think so. Input. Basic. How would we do this? So what I want is the scale to be plugged into this shader. But I don't want to do it like this. Because if I create this as an input, the problem is then I have to set it for each of them, and I would prefer not to do that. What I was hoping to do is use the object's transformation matrix and pull out the scale from there, and then scale our texture, our UV coordinates, our UV positions of our cube by that. So we can use the same cube and then just shrink everything and have it work like that. I think, right? I think that would work. I do not see a good way to do that though. So what's the next best solution? PBR, artistic channel, math, matrix. That's matrix math stuff. Save, Blackboard, main preview. Wave? No, we don't want that. Well, let's avoid shader graph for now because that's going poorly. And let us go to our surface shader thing. I totally lost what I was gonna say there. Manual surface shader. So this surface shader reference, I think, is what we want. Writing surface shader. There we go. Okay. So there are a bunch of extra values that you can grab. And they should be right here. And they don't they don't include the scale. So we can't get out the object scale from this. But we should be able to figure it out. Do we want to do that? I don't know if we do. Matrix. No. Huh. What's the best solution here? Is this something we should solve? I mean, yes, but should we solve it right now? Probably not, honestly. This might be better for a separate video, and we can kind of dive into it there. So yeah, let's put this whole diversion on hold, and let's focus instead on movement, because I think like there's three components to the game. There is the environment, which we've finished, not finished, but we have working. Then there is the movement, which we haven't started. Sure. And then there is the, like, it's not really combat, but like the interaction. And by that I mean like swinging on things. So there's a grappling hook that you can use to like grab and swing around asteroids. And there is a bomb that you can throw and stick into things, and that will explode. And that's sort of like the primary way of destroying all of this stuff. That's like the third part. And that's really like the last part that makes sense to do. But for now, we have asteroid spawning. I think movement. So let's do that. So this is our asteroid test scene. What we want is to grab our game controller, and I think that's it. Let's save that as a prefab, because otherwise I'm gonna try to modify it in one scene and it's not gonna go to the next, and I'm gonna get really confused. So let's call these our game controllers, and we can just drop that there. And so that has like all of the default values for our game. I think that makes sense. So let's create a new scene. Do I want to save the changes you made? Yes. Let's add a game controller. Let's do that. Main camera. Cool. This is an Asteroids VR project, or this is a VR project, a lightweight render pipeline VR project. So it should have all of Unity's VR stuff already. We just need to actually tell it to use it. And so I think that's the next thing. So the way I've gotten around it trying to launch Steam VR when I'm using this is I have set the default to be none. So project settings, modules, project settings, there we go. Player. So these are our mixed reality or VR setups. And so the default is none right now. I'm going to set the default to open VR, which should be Oculus Rift, or not Oculus, but it should be HTC Vive, Steam VR, and other open VR things. I haven't used any of the other open VR things, so I can't really speak to them. But what it should do is when I run this, one, I'm going to need to turn these on, but two, it should get really laggy. And Steam should do its thing and hopefully not break. Big hope there. And we'll get this thing. Ugh. And there's that. My base stations still need to turn on, so that might take a bit. But we should get a main camera that is now controlled by this. Oh, well, that's convenient. They came on right at the right time. And so we do, which means that it's somewhat working. Not perfectly working, because obviously, like, there's no controllers. At least I don't think there's any controllers. There's no controller game objects, for example. And so that's sort of what we want to add. I'm going to store this up here because I'm probably going to want it again. Because really that's the only way to like work on your game without launching like a VR thing. And at least for me, traditionally, Steam VR is like the most buggy thing ever. And it will always just cause problems. So yeah, it seems to be better now, which is good. Let's go and grab the default scene. The sample scene here came with not a prefab, but a configuration. Asteroid flight test. Sure. And before we go too far into this, I should save what I've done so far. Like we've saved it to the point that we've saved it. But I should actually, like I said, this is all in a Git repo. So let's upload that into our repo. It's not public, so you can't grab it, but I do this so that I can, if I screw something up terribly, I can roll back. And so we have a milestone. We have a working like asteroid spawning world environment thing. And so let's serialize that and save that so we know what's going on. And I'm just going to add everything or stage everything. And then we want to pull out a few things. The asteroid flight test is that new thing we just created. So I am not going to commit that. And our like test material, I'm not going to commit either. But everything else, I think I want. So asteroid sphere-based environment. That's not a good. Adds the ability to spawn and track asteroids in a sphere around the player. What else does it do? To ensure they stay nearby. Also improves the physics of destroyed asteroids. Sure. Right. So that gets committed, and that way we just have, if anything goes horribly south, I can roll back to that point, and we'll at least have some stable version that I can use. And then from the rest of this, I want to jump back to this sample scene because Unity comes with this XR rig, which is a little bit more than what I have. And so what we should be able to do is use this, and you can't see it. Bad example. But what this does have is tracking for, we have the floor, the main camera, the left hand, and the right hand. So let's add a cube. That's not the right hand. Let's add a cube. This is a terrible example. Why isn't this working? No, this is okay. Well, I'm just making a fool of myself, I guess. Why? Okay. Huh. It would have been smart to test this, I suppose. But we can move our camera closer. Too close. There we go. That's probably the problem. We are far too close. 0.1, 0.1, 0.1. That is much, much better. I'm going to be able to see that compared to the other things. Left hand, we'll add that as well. Reset the rotations and do everything else. Cool. And then for the left hand, we will swap that out for a sphere, just so we have some reference. And then in our game, we can see the sphere move when I shake this controller. And if I pick up the square, we can see that. And it seems to deactivate when it can't track the object anymore. So the cube is now under my desk, and oh. Okay. So they just like glitch off into nowhere. That might not be ideal behavior. One of the things that can fix this is a toolkit called VRTK. We are not going to be using that at first. We might transition into that. Part of the goal of all of these like abstraction things and building everything without VR and with VR is that hopefully we can plug that in without breaking a lot of things. And if we ever need to like upgrade it or do anything else, hopefully we can keep it as standalone as possible so that nothing bad happens. But yeah, that's sort of where we are. That light thing is tracking, but whatever. Also, my desk is in a poor spot for the tracking for the lighthouses to actually track it, because I have one over there and one over there, and I am like in the corner of where they are. So we're just gonna deal with that. But what I really want, the reason I came here, is I want to grab this this XR rig. Let's add that to our prefabs. And this will be our player. And so one of the cool things is now that we have nested prefabs, I should be able, well, I don't know if nested prefabs have anything to do with this, but what I'd like to be able to do is have this XR rig and have a copy of that, and then be able to create additional add-on bits. So like if we have fun little controller things or whatever, we can attach those as extra prefabs onto this and use some of these tracking points, because effectively all this is doing is having a tracked pose driver attached to it. And each of those are just moving it in to be aligned with this specific thing from Unity. So in this case, this is tracking the head. There's also things like tracking the left, right, or center eye. And yeah, this one is tracking the left or right hand controller. And then there's a remote. So if you have a like a Vive tracker puck, that might be a source for that. But hopefully we don't really need to get into too much of that. Yeah, we've poked at that. We can save that, and I think that's it. We need to now jump back to this flight scene. We have our game controller. We have our main camera. I'm going to delete the main camera actually, and attach our XR rig to 000, which means we should just be centered in the center of everything. Our game controller is currently broken because we don't have a tracked object. So I think we want to procedurally track things. And so what I'm going to do is set this tracked object to be equal to the main camera object. And so it will find the main camera and assign that, rather than trying to be smart about it. Because if we try to be smart about it, it's if we try to like move this around, it might get a little bit hard. So I could just drag this main camera over and it works. But I'm not sure if I want to do that. Instead, it seems like it might be better to have a script and to just say track main camera. Maybe? And so what this can do is in the awake, we can do a git component of our asteroid spawn controller, set the tracked. Is that the right thing? No. What was it? Global tracker, sphere, asteroid spawner, this. Okay. So find our sphere asteroid spawner and set the tracked object. This is a function. We should invoke it like a function. There we go. Tracked object equal to the camera main dot game transform. And so that should have it follow the main camera, I think. Does that make sense? The other alternative here is to find something that is tagged with the player, which we can tag this XR rig as a player, and then use that. So if I open this, open the prefab, assign it the player tag, what we can do is search for an object with player as the tag, and then track that. And that actually might make more sense. Let's do that instead of doing this, because this is kind of janky. So game object dot find with tag equal to player, and get the transform out of that. And so this is going to update our attract object with the new player information, and that should make it possible for us to follow them. And then we don't need this object anymore, so we can actually destroy it. Destroy this. And so really this should just exist for like a frame, and then we'll delete itself and we won't have to worry about it. And I think that makes the most sense. I don't really know. Kind of making that part up, but we'll see. All right, so that needs to be attached here. And I think we're good, right? So if I do this, it should get updated right away. And there we go. And now this should be able to like look around inside of our space and see all of these nice wooden asteroids. And we have, oops, totally lost tracking. There we go. I can't see the hand because we don't have any objects assigned to it anymore. But it's working, which is good. And it means we can actually kind of move around and cause things to spawn or despawn, and hopefully get flying around. So let's add something here. What is the best way for us to move our player? So in the past, this has been done with rigid bodies, and that's great, except when it isn't, because when we start using physics, physics can break, and game physics can break a lot. And when that game physics breaking a lot is tied to your head, it isn't as fun of an experience or as amusing. It's nauseating and not good. But I think it's still the best solution. So we might try that. Rotation in the past for what I've done. So, well, this might make a little bit more sense. I want to start this and kind of get a better idea of what is actually happening. So we have the camera floor offset, and then our main camera. And so what's happening here, tracking space stationary. I don't want it to be stationary. That's not what we want at all. We want this to be room scale. Open. Room scale. Yes. Great. Let's back out of that and let's see what happens. So camera floor offset is 0. Main camera now has a height. So the first thing we want to do is create a capsule collider that is attached to our main camera, is centered at half of that Y value, and has a height equal to the Y value. And what that will mean is that we now have like a person effectively that we can scrunch up and down. We're assuming in this case that the person isn't jumping, because how do you jump in space? Also, in my experience, jumping in this game is no fun, because you get so disoriented that you don't know where you are anymore, because you're literally doing flips and things. So let's not do that. Instead, how do we want to do this? Let's create something entirely separate that can do physics. Overrides? Apply. Oh, yes. Okay. So that's how that works. So let's do our physics bodies. Physics body. Sure. And let's add our capsule collider. Like that. And so we can set that to like, not that. We can set our height to like 1, and our radius to 0.2. And what that ends up getting us is something like this, where we just have this capsule. And now this isn't centered correctly, nothing's great, nothing's really working. But what we can do with this is then expand this to be dynamic. And so we're going to update this physics body to actually move our player. That's the goal. And by putting all of the physics stuff on this one thing, I think we're going to be in a much better spot. But I don't really know. This part is at least 50% guesswork. Well, the whole thing is kind of guesswork, but let's apply this just so that the physics stuff becomes part of this. And let's actually create empty. Let's do a body. And we're going to move this capsule collider onto the body. That didn't work. Okay. We're going to remove the capsule collider. And we are going to add it onto the body. Like that. So 0.2, 1, sure. All of that's fine. We're just doing this so that it's a little bit easier to follow. Overrides, apply, sure. And then scripts, player, we'll create that. And we are going to do a physics thing. Just because there's going to be a lot of physics going on in this project, I'm going to create an entire folder for physics stuff, because physics is like literally the entire game. So yeah, let's do a player body capsule controller. Yeah, sure, that makes sense. We'll call it that. And so what we need is a public capsule collider, and a public transform of the player head. And a public float of height padding. Yeah. So why I'm adding a height padding is because this at some point is like here, maybe somewhere in the center here. And so if we add a height padding, we can add some extra height onto this above whatever it is, which should mean that things can go bigger. And we're also going to add a public float min height. Does that make sense? Let's not do that. Right? Because I think if I understand this correctly, I should be able to go here, set this height to like 0, and we get a ball with a radius of 0.2. So the minimum height isn't necessary because it'll be clamped by the radius. At the worst case, we're just going to get a sphere. And so we should be able to work with that. All right. So with this, we have our height padding that increases it slightly. We have our collider. Body collider, just so we're not overlapping with an existing thing on the mono behavior. That just doesn't make sense. So in the update, we are going to update a few things on the body collider to match what the player head says. And so body collider dot center equals vector3 dot up times 1/2 of the player head dot y dot position dot y times 0.5. I think that makes sense. So we're setting the center of the body to be equal to the head with some additional movement. This may not be the best solution, actually. Let's set this to a new vector3. Actually, before I start tinkering, I wanna check something, because I have a suspicion. I'm assuming it can only move on the y-axis. I don't think that's right. Yeah. So you can see how we have these x and z coordinates as well on our thing, and those move when I move this, because I set it to room space, which means you can actually walk around. And because you can walk around, this doesn't work anymore, because we're just using the y. So we actually need to persist that x and the z so that the capsule collider stays positioned with our camera, or with our player head. And so we have this, and this. That's not going to work. Instead, we want to create a new vector3. Does this have a getter and setter? It does. All right. So we can do center dot x or dot y equals player head dot position dot y times 0.5. Maybe not. Okay, we can't do that. We have to do a new vector. New vector3, like that. And we can do player head dot position dot x, player head dot position dot y times blah, and then player head dot position dot z, and that will get us all of these values. So effectively, we will have centered our body, and then we want to set the height equal to the player position dot y. Body collider dot height equals this. And so what we should see now is we should see that capsule collider following us around. So if I attach this onto our... Where do we want to put this? Let's put this on a new game object that stores our behaviors. That may be overkill, but we're going to do it for now. And that will just allow us to have a specific thing for tracking behaviors of our object in its own little space. I don't know, that seems way too much, but we're going to do it anyway. Height padding, we don't actually use that right now, but it's there. And then, yeah. So what we should see is we should see the top of the player capsule. If I were to select this, intersect with the middle, or with the top of where this thing is. And as this goes up, our capsule gets taller and shorter, which is perfect. It means that we actually have some sort of player controller and it moves around with us. So as we move around our play space, we will have a player that is dynamically adjusting their height So if we have like a really small crawl space, we can actually duck down and like crouch under the floor and then scoot under it and then stand back up, and everything works. But I think that seems good. So I'm pretty happy with that. The downside of this is if you like lean over, this capsule is going to follow you. Which I don't, it means if you try to like lean over an edge or something like a railing, you're going to just hit the railing and be pushed back, which isn't great. I just don't have a solution for that. VRTK does. They have a leaning controller, which we might take advantage of, but we don't have that right now. So we're rolling our own, and so this is just going to be how this works. The height padding, I'm going to add 1/10 of a meter onto the height. Whatever this is what? 3-4 inches? Question mark? Total guess. And that's not 1/10 of a meter. That's much more, or much less. But what we can do here is do height plus. Ooh, that's it. That's not gonna work, is it? Float height equals player head dot position dot y plus our height padding. And so we need to update this height because otherwise both of these calculations need to be based off of the same value, or they're not going to return the right thing. We're going to get lost and it's not going to work. So this gives us a way to kind of make that work. So I think now we should have at least a little bit of like the padding added in. The value is almost certainly wrong. I'm imagining too much. So let's do 0.5. And the reason I'm doing this is just so because it's going to be centered at like eye level. If I don't add this padding, what's going to happen is like if something comes towards your head or is near your head, you're going to be able to like push part of your head through it, and that doesn't seem right. So we're going to be modifying this. The other potentially weird thing is because we're changing the size of the collider, I think it's possible that you could actually like stand up into things, and because the collider expands, what might end up happening is you might like shoot things off into the distance. We probably don't want that to happen, but right now it's going to. Yeah. So you can see now the top of the head is just a little bit higher, and that's fine. We can tweak that as we need to. I'm not going to do it here because it doesn't make sense. So there's our player. We have two controllers. They aren't really doing anything right now. I think the first step is going to be movement. And so we have collision, which means we can hit things. We don't have a rigid body attached to our player, so they're not going to be able to do anything. I don't want to worry about rotation right now because rotation is hard in this game. But I think we can, before the end of the night, what I would like to get done is the ability to pull these triggers and have you move in the direction these controllers are pointing. And based off of the distance or the strength of the trigger pull. So if you pull it halfway, you'll go slower than if you pulled it the entire way. And that way you can kind of like point in a direction and sort of fly around the map. And that will give us like a way to explore and work in this environment without having to do anything else. And I think we can call it done at the end of that. And then we can pick it up maybe tomorrow and get the rest of it done. Maybe rotation, because rotation takes a while. So I think if we can get those two things done, we should be good. There is no way to track presses. Like there's no way for us to track if a hand is pressed or which controller button is pressed. That doesn't exist. Not right now. So VR. What are we gonna get? VR devices input. Input for open VR controllers. There's all of that. So we want number 7, the trigger. Those get confusing, but Unity button ID. Okay. So the hard part with using Unity's VR implementation is it means that we need to actually map all of this ourselves. And so we have the left controller trigger and the right controller trigger, which map to the button ID of 14 and 15 respectively. Okay. So how can we do that? Input.get axis raw. Get axis name. So that would require us to actually have assigned these, or is there a way? Reset input axes? I don't know. One of the advantages of VRTK is this is a solved problem, and so we don't need to actually do this. But I think it'll be relatively easy, question mark. So if we do this and say like left controller, that means we need to go into the Unity input system up here in project settings. There we go. Go to input axis and add one for ourselves, which we haven't done. I don't know if we want to do that. Is there a better way? Do they have any examples? Maybe they have examples. I don't think so. The event system. Do we get events when these things start happening? An input module is where the main logic of how you want the event system to behave lies. They are used for handling input. Must be components on the same game object as the event system. What's an event system? What? Player body capsule collider. What did I break? Something broke because Unity lost all my scripts. What? Oh, what? Hold on. What happened? What? Re-import. There we go. It's back. All right. Weird issues. Unity lost our game object or our mono behavior. I don't know why that might be. Opening file failed? Well, that's not good. Okay. That's some Unity bug. We can get back to that later. Let's figure out what an event system is, because that seems like it could be useful. Event system. First selected. Is this a UI thing. This feels very much like a UI thing. But maybe I'm wrong. Event System Manager, Graphics Raycaster. I'm pretty sure this is for Unity's UI. So we're not going to do that. We're not going to use that because that's just asking for trouble. Instead, let's see. Is there a way we can be smart with this? Because what I'm concerned of is I may end up, like right here, you can see already the problem of there are specific things for Gear VR and specific things for everything else. And I don't want that. because if we start doing that, then everything is going to be hard. And so what I would like, update and before render, that's updating different things. So how, those are inputs. Okay. Well, I guess we're going to do this the fun way, and then we'll fix it later. So we need to set up axis 1D primary index target, secondary index target. Okay. We're working on an HTC Vive, if I haven't mentioned that yet. So this is going to be our left hand trigger and our right hand trigger. So there's all of that. That is a lot of joysticks. We want to use number 14 and 15. If I'm looking at this right. Unity button index. Well, that doesn't seem right. Let's see. So those what am I doing? Left controller trigger, left controller trigger. Why are there two? Unity access ID is 9 and 14. Okay, got it. So what's happening is there is a button at the end of these triggers. I'm assuming this line is for triggering off of that button press. And that will happen for both of these. The next line is an axis, which means it can go, it's more of a instead of a Boolean, it's a linear thing. And so what that means is that we have 0 to 1 instead of true or false. And so I want axis 9 off of this. Joystick axis 9. Axis 9. And then the right hand trigger is axis 10. Just going off of sequential things, yeah. So right hand is 10, left hand is 9, which means let's write something that will automatically capture those into some script, and then we'll read from that script to do everything else. And that way we can kind of more easily control this stuff. So we are going to have physics float player flight settings. Settings is not a good name for that, but we'll use it for now. And so this is going to store 4 values. So float of the public float of the left hand strength and public vector 3 of left hand forward. And then we'll do that same thing for the right hand. And so what this is going to do is make it possible for us to track the information here and then have something that will set them and something that will act on them. And this means that as we update that tracking behavior, whether we plug in some new system or whatever, the stuff that's relying on it doesn't break. So it's sort of an intermediary and prevents them from interfering with one another. And so the right hand and left hand forward is just going to be the up vector of this. So like if we have one of these controllers, ideally it's like that. And so wherever that direction is, that will be the forward vector, which is what we're going to use to apply force when we pull this trigger. So when I pull the trigger, we'll go along that. At least that's the idea. We'll see how that works. And then the strength is going to be the strength of the trigger press. So that's where the input thing is going to come from. So we need another input thing, which is going to be equal to our player input control, player trigger input controls. There we go. And we're going to just kind of have this here because it needs to go somewhere. And I don't want it in that same thing in the settings thing that we just created, because if I put it there, what's going to end up happening is we're just going to end up with one massive amount of code that's doing a whole bunch of different things. This allows us to kind of keep that separate without getting too messy. Actually want that start back. There we go. Private player flight settings, and we are going to add a require component of the type of that. And so that's just going to tell Unity that we need a player flight settings attached to the same game object. That makes sure that things are just going to be fine. And then we can go and actually grab that. So flight settings equals get component of player flight settings. There we go. And so now that we have that, we can actually update that. So flight settings dot left hand strength equals some value, and right hand strength equals some other value, and those are going to come from the input system. So right hand, left hand, input dot get axis, and these can only be between 0 and 1. So we have left hand trigger, I think is what we called it, and right hand trigger. And so with these, we will have a strength value. We can multiply that by the force, but that will happen somewhere else, not in this. And then the other two things we need is a public transform of the left hand and a public transform of the right hand. We could write a script to go and look these up based on the tracking components that are being used. I'm not going to do that for right now, just because that's extra stuff, and I imagine we're going to be changing this a lot, and it doesn't make a lot of sense to make this super complicated right now. So if we do flight settings dot right hand up or left hand up, left hand forward equals our left hand dot up, I think is the correct thing. I want it to be along the axis of where you're holding, not like forward, because that doesn't make sense. Like effectively we're thinking of like a thruster or a jet engine or whatever running through the controller, and so we want it aligned with that. And we can actually add some extra components by doing it this way, so we don't actually physically have to track the controller. We can attach some component to that and orient it in a special way, based on our model or whatever, and then use that instead. But we're not, so yeah, not there yet. And then let's do a right hand forward. There we go. And so assuming this is fully configured, all of our settings are done. And these should be public on the flight settings stuff, which means we should be able to see them. So if I go into behaviors and plug in the flight settings and the player trigger input capsule thing, grab the left hand, put that there, and the right hand and put that there, everything should be good. I should be able to save this and play it. And now if I hold the whatever hand this is up, it looks like it's the right hand. And so it looks like up is perpendicular to this, so we actually want the forward vector. So let's swap that in quick, just to make sure everything is good. And I never tested the triggers, but we'll see, I guess, in the next few seconds if this works. So both of these should be able to point straight up, and we should see a Y near 1, and we do. And if I pull both the triggers, we get 1 on the trigger hand strengths as well. And those are axes, so they'll change. But it also means we can kind of rotate these around, and we will get a world space position or direction of the controllers, which should be really handy. It should mean that we should be able to fly around now, because the only other thing we need to do is attach a rigid body to our player and then apply these values as a force on that player. And then I think we're done. So let's turn this into a rigid body. We are going to add some constraints here just to prevent this from going horribly wrong. Rotation, if something hits us, we don't want to cause the player to rotate. That is just asking for horrible, horrible things to happen, because you'll end up rotating out of control and it will just be nauseous. So let's not do that. And so yeah, you can't rotate, but you can move. So if something hits you, you'll bounce or be bounced off and fly into space. And then, now that we have the rigid body, let's apply this to our prefab. And then we just need one extra thing, which is actually going to apply these forces from that settings object onto the rigid body. So this will be our player flight controller. And everything is ending in controller, and I'm not happy with it. But we can grab these things we used for our settings, because we're going to do the exact same thing. There we go. And so that grabs the settings. We also are going to need the rigid body. So public rigid body, our player rigid body. Ooh, that's not right. Player rigid body. And then in the update, we can do player rigid body dot add force equal to our flight settings dot left hand forward times the left hand, or times the flight settings dot left hand strength times some force thruster force. So that'll be the maximum amount of force that we can have, and we're just multiplying all of these by whatever that is. And we'll do the same thing for the right hand. Like this. There we go. And create a public float of the thruster force. And then hopefully we should be able to fly around. That'd be cool. We've only been streaming for like 3.5 hours, and we've got a full a working environment, and theoretically we can fly around. So I'm pretty happy with that. I was hoping to get this done by the end of the weekend, and it seems like that actually might be possible. So that's cool. Player flight settings, player flight controller. There we go. And then we need the rigid body right there, and the thrust force. Let's set it to 10, because really all we need to see is that it moves. We don't need it to move that much. I'm gonna zoom out just so I can see, and we'll just do one thing, and there we go. We can fly around. Haha, cool. All right. Well, that was easy. Well, I mean, maybe not easy, but we're done. Cool. Where'd I go? Oh, I went up. We didn't leave anything behind, did we? Oh, and there's no friction, so it's just gonna keep going off into to infinity. We should add some friction. Because otherwise, like, I get space, and you just keep going forever. But that's a long way to just float off into infinity. So what I think we'll do is let's create a function for the braking force, which is going to act in the opposite direction of your current velocity. So if you're going in one direction and there's a braking force, it will push against you and kind of move you back. Float braking force. And so this will probably be less than whatever, but effectively what I wanted to do is, like, it will act like friction, but it won't be friction, because it's actually like going to disappear when you're thrusting, and will only appear when you aren't. And so what this is going to do is float braking amount. And so what we're going to do is take the mathf.max do I want to do this way? So there's three formulas I'm thinking of. We can do the floatf.max of the flight settings dot left hand strength and flight settings dot right hand strength, and then subtract 1 from that. So 1 minus, ooh, that's not a 1. 1 minus that, which means if you are have one thruster that is at max force, there will be no brakes. The other alternative is to do a min, and then it'll be whatever your second hand is. So if both of them are at max speed, there'll be no brakes. But if one of them is not even pulled, there will be. So you can have like more control in that sense. The third option is like a middle ground, and that's to take an average of these two. So to do that plus this, and then divide it by 2. And then if you pull 1, you will have half of your brakes. And if you use both, you will have none. I don't know what the best solution is, so we're going to go with this one, because I think it makes the most sense. So like you can have like full power mode of like abandon all hope, just go, or you can do the other one, or we can just have a constant brake. That may make sense. We could do that too, and just have a constant thing that's constantly trying to keep you at your current position, effectively introduce friction. And if we do that, the advantage is we don't actually need any code, I don't think, because we should just be able to go here, grab our mixed reality rig, and add some drag. like 100, sure. And that should mean like if I try to fly up now, where am I? We don't even move really. Let's reduce that. Yeah. And so like if I hold the trigger, we have moved up like a full half of a meter at this point. That's not right. There, we've moved up 7, 8 meters, which is almost nothing. If I reduce this to like 1, maybe that makes a little bit more sense. Yeah. Oh. Oh, that's broken. That's very broken. What's going on here? Wait, why? What? What? Hold on. What? Physics body? Why does it have a height of 30? And why is it over there? What's going on? For main camera? Why did that happen? That doesn't make any sense. Hold on. I've broken something horribly. This player body capsule controller does not like it when we fly off into space. Oh, ha! We're using position. That's why. Local position. Fixed. That makes more sense. Because we were using world space position, as we went flying into the sky, it was thinking we were much higher, like our height was growing when we actually weren't moving our head. So that should fix that. Cool. But yeah, dampening seems to work. Like adding drags works. You have less control of it, but I don't know if that's a bad thing. And this is how I've done it in the past. So like you hold up and then the drag slows you down over time. And what we could do is modify the drag based off of one of those braking amounts. Let's try that. Let's see how that feels. It'll be hard. This is going to be something that I'll test off stream. But we can take this braking amount and do player rigid body dot drag equals our braking amount. And so it can be kind of hard to like tell how this feels without actually like getting in and playing it. And especially since we don't have like rotations and things like that we have like a semi-done movement mechanism. We're kind of in this weird spot of like it might work. Why are we going off to the side? That's weird. That's even weirder. Wait, what? Hold on, that doesn't seem right. It does seem to work though, because we have a drag of 1, and then as I pull the trigger, oh, I need to pull both of them actually. That might be part of it. Yeah, so if we go down, we lose that and we go real fast. Because we're getting double the speed from both of these controllers, plus we have no drag. So suicide mode of like just crashing into whatever, which probably is not what you want. We probably want some amount of drag because this is really fast. When you're actually in that would be going like real fast. We went 100 meters in that time. So yeah, too fast probably. But yeah, that these values, I guess, are something that I'm going to have to tweak. And it doesn't make sense to do them on the stream because it's just going to be tedious, and I'm just going to be plugging values in and then putting a headset on and then trying it. But yeah, I think we're in a good spot. I don't know why. Okay, now we go up. Do we go up? Hold on. I'm paranoid now because it doesn't feel like we go up. It feels like we go in some other direction. But maybe that's just me. It seems like everything is working well. But I think that's it for now. We can pick more of this up tomorrow, maybe, if I have time. But I think we're making pretty good progress. We have spawning asteroids, and we can fly around. So the two remaining things, the two things we need to get done is rotation, which is optional, and then like something to destroy the asteroids, and that's the next thing. So I think I'll go and grab some like assets or something for this. Maybe we can just do that now. Let's see here. Go in here, asset store. I have like some skyboxes that I've kept here for a while. Let's see here. Space. That's not going to work. My assets. I have too many of these. Procedural planets, that could be cool. VR locomotion. Space. No. Skybox. There we go. So these are just like super basic space skyboxes. I've used them in the past in a bunch of different videos and a bunch of different projects, but it's, at least for a space game, it's a super easy way to like set the scene. And so let's grab one of those, drop it in, and then we can kind of pull things to a stop and come back and do whatever comes next. So this can just go, and there we go. Instant space. And so lighting doesn't seem right. It seems very bright for blue, but you get the idea. Let's rebuild that actually. Now that we've done all of this, let's save that, rebuild our lighting. How do we do that? Ambient, generate lighting. That might take a bit. No? Okay, cool. I guess we don't actually have any meshes, so that's probably super quick. Doesn't seem like it made any difference. That's probably because our directional light is yellow. Who would have guessed? Let's make that a little bit more thematic and green. Like a cyany, greeny, bluey thing. Like that. Yeah. And then let's rotate this around. Should it come from over there? Sure. I guess that makes sense. It looks a little bit more like it fits in. But we can poke at that. If anybody has any questions they want to ask before I sign off, feel free to drop them in chat. Otherwise, I will end the stream and we can come back to this after I've tweaked some of these things and have eaten dinner and yeah, and slept. But yeah, I think that's it. So yeah, thanks for tuning in, everybody. There's been a few people who have dropped in and then dropped out and asked cool questions and had cool pointers and suggestions. Somebody wanted to add a mongoose. Weevil. Sorry, somebody wanted to add a weevil. I don't think we're going to add a weevil. but thanks for the suggestion. And yeah, let's see. I think we're good. Yeah, I don't see any other questions, so I will end it here, and I will try to be back tomorrow. I don't know when. Whenever I have time. But the goal is to get this done to the point where I can ship this to somebody and they can play it by the end of tomorrow. I think it's a little bit ambitious, but it's not intended to be like a full game. It's intended to be like a demo where somebody can play it and kind of get the idea and give some feedback and say, this works, this feels awful, I want you to fix this. And then I think for future development, we can kind of iterate on it in that way. And then based on that feedback, we can turn it into new videos or new live streams or whatever makes sense. But at least this way we're making progress instead of like trying to figure out when it makes sense to like cut something into a 30-minute section for a video, because I was having trouble with that. And live streams have just worked way better to actually get things done. So yeah, anyway, I'll sign off. Thanks for tuning in, and I will see you in the next video. So until then,